Okay, can let's take a look. So question 13, you have a problem with it, is it? This one?
Yeah.
Okay, let's take a look at the question first. So in question 13, you have a box. It contains 8 balls. 3 are identical, 5 are different. 3 balls are to be picked out of the box. Order in which they are picked out does not matter. Find the number of different possible selections of the 3 balls. So the key idea here is there's identical and different. Oh, then you need to consider all the cases. So you selected all different, then you do 5 choose 3. That is actually okay. Then if it's two different, if there are 2 types here, okay. 2 types here, if you want, right, it's really just identical, different. Identical, different, or different, different. Oh, sorry, cannot. That's the same already. So these are the only 2 ways, right? Then you need to consider how do you get these 2. The answer is not so simple. 5 choose 2 times 3 choose 1. No. This should be okay. This part, all same. 5 choose 1 and then 3 choose 2. Also not so accurate. I think I'll just go to the solution. Is that okay?
Yeah.
Yeah. Okay, so over here in the solution, what you're really doing here, let's say, look at method 1 first, is you're considering all the possible cases. So all 3 identical, so I use I, or 2 identical and 1 different, or 1 identical, 2 different, and all 3 different. Okay, but that is really equivalent to, if you want to select 3 identical, it's the same as selecting none of the identicals. It's the same. Okay, the number of ways to select 0 eyes, sorry, to not select 0 eyes, is the same as having those 3 eyes being 3 identical balls being selected. Okay, likewise for the other cases, 2 identical is selected means 1 is not selected. 1 identical is selected means 2 not selected. 0 of them selected means 3 of them are not selected. So we are going to count these number of ways instead. Also, let's think about it. How do you select 0 of those identical ones? I choose 0. How do you select 1 of those identical ones? I choose 1. Then how do you select 2 of those identicals? I choose 2. How do you select 3 of those identicals? I choose 3. Okay? Then you add them together.
So I don't permutate because they say the order in which they are picked does not matter.
Correct. Order does not matter means you don't need to permute them.
Okay.
You don't need to times 3 factorial. Okay, then how about case 2? Case 2, they are splitting into 3 cases. This one is all 3 identical, all 3 different, 1 identical, and 2 different. Here, what happens is all 3 identical is the same as the first method, 5 choose 0. Then here, all 3 different are a bit different because what they are doing is they are considering there are 5 different balls. So 1, 2, 3, 4, 5, and then there's one last group that is consisting of the 3 identicals. 3 identicals. They just keep it as one group. So 1, 2, 3, 4, 5, 6 groups. Then you just want to pick 3 of those groups. Yeah, that will confirm, that will ensure that you have a different selection each time. Then for this middle case, it's 5 choose 1, 1 identical and 2 different. So how did they do it? How did they do it? Why is it 5 choose 1? Because if you pick, actually I'm a bit confused. Why is it 5 choose 1 again? Oh, right. Maybe it's more like 1 identical and 2 different. Let me think a bit. 1, 2, 3, 4, 5, 6, 7, 8. if you pick one identical, then you need two different. So right, correct. Okay, this is the case where you have already selected one to be identical. One of those balls locked in as an identical. Oh, so that means that the other two you want it to be different. Can you select I again?
Cannot.
I, then I again, then D? Cannot, because there's a repeat. I only want one identical, which means that once I lock in an I, the other two positions, what must they be? Different. Right? The other type. So once one of those I's have been chosen, you only need to pick two more balls from among these five different balls. That's why it's 5 choose 2. Hey, sorry. Should be 5 choose 2, I think. Let me just quickly check. Is the answer the same if 5 choose 1 versus 5 choose 2? I think it's not the same. Okay, I am not too clear about this part. I will get back to you on this. But do you get the method one?
Yeah. Their second and third method always very weird.
Yeah. This one just go logically lor. Count the number of same and different. Then you do it case by case and add everything together. Okay, can. Then we'll move on. Question 14 is okay. Question 15, this one not okay. Let's read the question first. 5 people, of whom 3 are women and 2 are men. Okay, here. To form a cube. Find the number of different arrangements that if no 2 people of the same gender are to stand next to each other. So this is a similar question to one of the tutorial questions we did, which is about the couples, men and women. Then you want to make sure that no 2 same gender are side by side, right? And the trick here is to know that there's a pattern here, which is man, woman, man, woman, man, woman. You must alternate, right? Here in this case, there are 3 women and 2 men. So how would the pattern be like? 3 women and 2 men. 3 women and 2 men. Let's consider some of those ways. 2 men. Can we have this pattern? There's like 1, 2, 3 slots. Then I just slot in the first 2 positions. Is this okay?
Yes.
No, it's not okay. Why? No 2 people of the same gender side by side. What happens over here?
Oh.
2 women are side by side. But what if I consider the other case? What if I put it over here? Is that okay? Cannot again.
No.
This part. Do you start to see the problem already with your method? 4 3 side by side. You see, when you did 4 choose 2, okay, I show you your solution. When you did 4 choose 2 then times 2 factorial, what you're doing is you are writing down 3 women, and then you draw these arrows that represent the slots, the positions where you can slot in. Like, okay, let me erase the M first. There are 4 empty positions that you want to slot in the men. When you choose 2, it could be any 2, and those 2 can include this position, which is very bad. Because the 2 women will be side by side.
Oh.
Or it could be these 2 slots. Then 2 women will be side by side. So you're counting a lot of cases that are not relevant here already. So the trick to do this question when you see alternating pattern or men women must be separated is the following. You need to first consider how do you construct men and women side by side. There's only 2 ways. Men, women, men. Maybe I use different color. I'll try to make it different color. Let's say women. Where should the men be sorted in?
Like between the first and second and the second.
As well as, yes, correct. So that is one way. What's another way? Is there another way? Oh, sorry. In this case, is there another way? Let me see. 3 women, 2 men. Usually you would want men, then women, men, then women, and then finally last women. But then we can't really sort it in here. Let me think a bit. It's an odd number. This is 5 people. Okay. Oh, sorry. Yes. Sorry. Okay. Got it. Yes. That's right. So you realize that there's only one way to position men and women, right?
Yeah.
No other ways. You cannot slot the men any other place. If not, they won't alternate anymore. So that means that we are locked in one possibility of the men and women. But now these men and women are actually distinct. So that means that we cannot just say, oh, men one way only. It's actually how many ways? They can men number 1 and men number 2 on the left. And men number 1 on the left, men number 2 on the right. You can also have men 2 on the left and men 1 on the right. Swap around, right? In other words, 2 factorial ways to arrange them. That's why we have this 2 factorial over here. But then how about the women? You got women 1, 2, 3. What do you need to do to these women? You can also rearrange them, right?
Yeah.
Rearrange them. How many ways? 3 factorial ways.
Yeah.
Okay, then you just multiply and you get your answer. Okay, let me give you an extension question. Extend. Let's say we have 3 boys, 3 girls. Then we want them to sit such that no 2 boys and girls, no 2 same gender are side by side. Sit, no same gender side by side. Side by side. Basically the same question as before. It's just that instead of men and women, I changed to boys and girls, and now it's 3, 3. So how many ways? It's like, maybe I'll just go through this. Then later I give another extension question. You can try that question. So for this trick, you need to do the same pattern here. You go and list down all the 2 possibilities. List down the few possibilities, and you will come to the realization that there is only 2 ways to do it. If you have 3 boys here, where can you insert the 3 girls into the slots? There are 4 positions. In this case, because there's the same number of girls, I think it's obvious. You can just put maybe like this, or alternatively, the second way is you have 3 boys, you put the girl on the left, this one on the left. So there are only 2 ways, right? 2 unique ways. But these boys are distinct, these girls are also distinct. So that means that within these 2 ways, we need to multiply by the number of arrangements. Right? This first way, there's a number of arrangements. How many arrangements is that?
Like 6.
6? Oh, that's not right. How do you think about the arrangement? You got 3 boys, so you want to arrange them how many ways? 3 factorial ways. Then you times, got 3 girls. How many ways to arrange them? 3 factorial ways. Is that 6?
I cannot do it like together, like everybody together.
No, your positions are fixed. You must make sure that they are fixed so that you can guarantee the alternating gender.
Oh, okay.
Okay, so you are locked in. These 3 positions must be boys. These other 3 positions are girls. Then you arrange them. So you arrange the boys 3 factorial ways, arrange the girls 3 factorial ways. Answer is 36, right? But of course, if you do it for case 2, I forgot to mention they are sitting in a row. Quite important, not a table, in a row, left to right. So their order matters. So in this case, girl at the start, then after that you alternate. Okay, this one is boy at the start, then you alternate. Like plus minus, plus 1 minus 1 plus 1 minus 1. But this one is boy girls, boy girls. Also, same thing over here. You will see that it's just 3 factorial, 3 factorial. Do you agree?
Yeah.
Then what's the total number of ways? 36 plus 36. But of course, a lazy way is to realize that they will definitely be the same, then just 2 times 3 factorial, 3 factorial, which is 2 times 36. Okay?
Yeah.
Now extend. Now let's say I change the exact same situation. This is extend 1, this is extension 2. Let's say we change it to 4 boys, 4 girls. Same situation. They're sitting in a row, and then you want them to alternate in the gender. How many ways?
Like 5 slots.
Use the same method. Case 1, case 2. What do you think are the 2 cases? Alternating gender. So how did I get these 2 cases? I start with the first position. I lock in one of the gender, boy. Then if I want alternating, next position must be what? Cannot be boy anymore, must be girl. Then what's the next position? Cannot be girl anymore, must be a boy. Then what's the next position? Cannot be boy, must be a girl. Then a boy, then a girl. Alternating. Can you see the pattern?
So I don't need to do like 5 choose 4.
Cannot. You cannot do that because over here, what's it? The position is more important. We are doing casework on the alternating pattern here. The alternating restricts the number of ways that you can do it by a lot. If you do 5 choose 4, you will overcount by a lot. You'll overcount by a lot of ways. This is a very, very restrictive, very, very strong restriction. So you must deal with this restriction first by considering the cases. So can you just try? What's your case 1? What's your case 1?
Like 4 factorial times 4 factorial.
Yes, correct. Then how about case 2? Wait. Maybe I hope you can see that picture. It's basically just the exact same situation. I just add in 1 extra boy, 1 extra girl.
Yeah.
Right. Okay. Can. I think it's obvious to you. Then in case 2, you just have to swap the order around. Case 2, you just have to swap the order around, or more like copy and paste. But then the G maybe just bring to the front. Also, start with one gender, then alternate. Start with one gender, then alternate. Start with girl, then become boy, then girl, then boy, then girl, then boy, then girl, then boy. And of course, it's just 4 factorial, 4 factorial. And that's in total, it will be 2 times of 4 factorial times 4 factorial. Okay? I don't know what's the number. Not important. Know the pattern. Okay? Only 2 cases.
Okay, so as long as it's alternate, I cannot use the
choose
thing.
Yeah, usually we'll count too much.
Okay.
Yeah, do these 2 cases. Okay, Ken. So likewise, since we're talking about cases, that's why we move on to part B. We also do cases. Whenever you see this even numbers, right, it means you have to do cases on your last digit. When you see this between 3,000 to 7,000, it means you have to do cases on your first digit. Okay? Is that clear? This is important. I should write this down somewhere. So even number, and they also restricted you to using digits 1, 3, 6, and 8. So for part 1, no digit can occur more than once. That's very lucky. It means we don't have to count so many different ways. All digits are distinct. And there are 1, 2, 3, 4 digits. So it means we're going to form a 4-digit number. Then last digit, because of because of the request for an even number, it means we know the last digit must be what kind of number? Odd? Can it be odd?
Cannot.
No, it has to be even. So what are the possible even numbers? 1, 3, 6, and 8. Which one? 6 or 8?
Yeah.
Right. So there are 2. Then that means there are 2 separate cases now. Case 1, you put 6. Case 2, you put 8. Okay. Show you the solution. 6 here, 8 here. Then after that, since we have locked in, let's just focus on one case at a time. Easier on our brain. Let's just make it concrete. Consider 6 to be that last digit. So 1, 3, 6, and 8. That means we only have how many options left? 1 or 3 or 8. Then we focus on the next condition they gave us, which is that the number must be between 3,000 and 7,000. So can it be then that means there's restrictions on your first digit. So if it's between 3,000 and 7,000, can the first digit be a 1?
No.
Can it be a 3?
Can.
Yes. Can it be a 8?
No.
Cannot. 8 will be 8,000 something, more than 7,000 cannot. If it's first digit is 1, it will be 1000, smaller than 3000, so cannot. So that means we're only left with 3 using this logic. So that's why here they put down digit 3. There's only one way. So since we already 1, 3, 6, 8, we already used up the we already know where is the position of digit 3 and digit 6. They are locked in already. That means that we only have these two ways that are free to permute. Okay, free to permute can be anything. Of course, there's not much restrictions here. Huh? There's only 6 and 8, so there's really just two ways to do it. 6, 8, or 8, 6. You can think of it as 2 factorial. Or you can think of it as counting down. First box got how many ways? 6 or 8, so 2 ways. Then after you put in one number, 6 and 8, one of them put down already, you're only left with one more. So one way, and 2 times 1. Okay? So that's why the first case one will be 1 times 2 times 1 times 1. Then for the second case, let's consider last digit is now 8, so lock in. 1, 3, 6, 8. 8 is locked in. Put a tick here. We only have these options left, 1, 3, or 6. Oh, that's from the even number condition and case 2. Even number requests for even number means your last digit must be even number as well. So it's either 6 or 8. Then now we are at the case 2 when the digit is 8. Then we focus on the second condition. Value is between 3000 and 7000. So it means your first digit must be, let's consider 1, 3, 6, or 8. Which one is not possible? First digit.
The 1.
1 cannot. If not, it will be smaller than 3000. So that means 3 and 6 are both possible. 3000 something, 6000 something. Both are possible. That's why over here we have two ways, 3 or 6. So take note that here, even though we say two ways are 8, doesn't mean we choose both numbers to be placed in that one box. Doesn't make sense, right? You can only put one digit. So that means that once, let's say, for example, we put 3. That means this 3 is no more. How many options do we have left? 1 or 6. Alternatively, we could have the first digit, we could have chosen 6, then 6 no more. How many choices do we have left? 2. 2 choices. That's why we have 2 ways here. Then after you put down one more on the second position, you're only left with one way. Okay, so 2 times. So that's why the number of ways will be 2 times 2 times 1 times 1. Okay, then you add together for the 2 separate cases. They are non-overlapping disjoint sets, non-overlapping cases. Therefore, you'll get the total number of ways. Okay, they are definitely don't need to go and what A union B equals to number of elements in set A plus number of elements in set B minus away number of elements in A intersect B. Don't need to minus. Just plus can already, because we have separated them into 2 cases that have no overlaps. Is that clear?
So case 2, do I use factorial also?
Factorial? No. We are counting. You see, when we are doing this countdown method, we are already considering the positions. Like for example, let me give you a simpler question. Let's say you have 4 t-shirts. Let's say you have 4 t-shirts, and somehow I don't know why you want to be arranging them in a row. Let's say you want to only have 3 of them. What's the number of ways? Here's one way that you can do it. You have 4 distinct t-shirts. Let's just call them T1, T2, T3, and T4. Then you want to arrange them. You want to only select 3 of them to arrange in a row. So here's one way that you can do it. You have 4 t-shirts, so you want to choose 3 of them, right? But you know the arrangement method, so you times 3 factorial, right? But here's another way. By the way, this formula is actually just for permute 3. You don't really need to know permute the formula, but knowing this for selection and then arrangement is more important. It's more general. But there is actually another way to do it, which is exactly what we are doing here in this numbers situation. What we are doing is we are counting. I have 4 choices. So my first position, how many choices do I have? 4. If I put in 1 shirt already, how many choices do I have left in the next box? Count down. Then after that, count down again 2. So the answer will be 4 times 3 times 2. This is exactly the same as 4 choose 3, the selection first, and then times 3 factorial arrange. Go and check with your calculator. Quickly check that they are the same. 4 times 3 times 2, 24. It's the same as 4 choose 3 times 3 factorial. So do not times 3 factorial anymore when you are doing this countdown method. All right. Can? Do not times factorial. No need to answer your question. No.
Oh,
Okay, then. Yeah,
okay.
yeah.
If they give the same answer, then why I cannot use the 4 choose 3 times 3 factorial?
Oh, you can, but that will be let me think. Because there is this restriction on the first digit, right? So it's a bit difficult. Maybe the only place where you are using this, you can use that 4 choose 2 and then 2 factorial is over in the middle. So it will be this green part out, which is it will be 2 choose 2. You have 2 digits, you want to choose 2 of them, then you times 2 factorial. Okay, for the others, if you are deciding to take 4 choose, wait, let me see what was your answer. Sorry, forgot to look at your answer. What do you do?
Um,
2 ways. Whoa, that's you consider 3 and 6. You must consider more cases because I think you missed out one of the cases, right? Which is like when the last digit is 8, the first digit can be 3 or 6. Here, when the last digit is 8, you only consider 6. You forgot to consider 3 and 8. You forgot that case. Yeah. Or you separate into 3 separate cases. That's okay. That's okay as well. But you just forgot this case. You see?
yeah. Okay.
So if you actually consider this case, then you will get the correct number. But what were you saying? You wanted to use choose. So what are you suggesting? What are you suggesting? This one 2 choose 2 times 2 factorial is just 1 times 2 factorial, which is 2. A bit silly. I think it's the more direct way is to just count down 2 times 1. What were you suggesting? You said
like the first digit cannot be like 4 choose 2 times 2 factorial.
4 choose 2 times 2. First, wait. First digit, you mean the first number is?
Like, yeah, for case 2, like the digit 3 or 6.
Whenever you must understand when you times 2 factorial, right, this the pattern we're doing here is we are first selecting the number. That's why we have a choose, right? Select, choose. Number of ways to select, number of ways to choose. That's why we use the choose function. Then after that, we arrange those numbers that we have selected. 3 factorial. 3 different numbers and can arrange in 3 factorial ways because they can move to different positions. Here, you're telling me you want to choose 2 digits, 3 and 6. Then you want to times 2 factorial, right?
Yeah.
Does that make sense? You only have 1 position. How many ways to arrange them? Only 1 way. Why need to permute?
Oh.
It's not 2. We're not selecting 2 digits and placing in 2 different positions. No, we're selecting 2 digits to be placing in just 1 position. This is really just a lazy way, case 2, of breaking it down into, instead of writing down a separate case 3, they're lazy. They want to do things a bit faster. They realize that you can just times 2 at the front. Of course, if you could have just put down digit 3 here and then you put a case 3, first digit is a 6 and last digit is a 8. Then you go and count. Also perfectly fine. Just a little slower. It's just 2 times 1 times 1. Also, actually, also quite fast. Not that slow. Okay? Yeah. Okay, good. Then how about B part 2? Repetition of digits allowed. So in this case, repetition of digits allowed means very easy already. You just need to consider what are the possible digits in the first position. You want it between 3,000 and 7,000. So can you have what are the digits? 1368. Which one can you not have?
The 1 and 8.
Correct. So 1 and 8 is out. We only left with how many choices? 3 or 6. 2 choices. That's why we have a 2 at the front. Okay. Do you get this answer correct? Actually.
I
Oh, you did. Okay. Then I don't need to go through. Is that okay?
Yeah.
Sorry, forgot to check. Just go through the ones you got wrong. 16 looks fine. Part 1, part 2, then part 3, something wrong. Let's see. Part 4 as well. Okay, 6, part 3, and part 4. 16, part 3, part 4. Okay. Alternate again. Your worst enemy.
Yeah.
Okay, let's read the question first. Find the number of ways in which the letters of the word elevated can be arranged in no restrictions. T and D must not be next to each other. You found those answers. Fine. Part 3, consonants, this guy, and vowels must alternate. Okay, so what you can do is to consider the bigger number. I like to start by writing down the bigger number first. Then I leave some gap in between them to squeeze in the new letter. So E and A, they must alternate. So how can we arrange it? Can I put E here and A here? Does that work? Cannot, you see, the T and D are meeting each other. Then how? Only 2 letters. Then I try all the different ways. Cannot. It just doesn't work. You see, the V and T meet each other. What's the problem here? What's the problem here? What's the problem here is that I was blah blah. I just jump straight to the question. I see LVTD, I see EA, then I just write down LVTD. But actually, where did this consonants and vowels come from? It came from here, elevated. So this is a very important idea. This kind of question where they give you some words, right? They will always have repeated letters. Do you see that the E actually appears 3 times? It's not just a single E.
Yeah.
That's a problem. It's actually still 2 extra E's that are available to us. I forgot to write down. I forgot to consider. I could have placed my E's. I still have these E's as well. So what you should always do when you have a word, right, is to break it down. Let me see if you did that. Yes, you did this. Break it down into the different types of letters and how many copies. I like to write it as E times 3, then L times 1, then V times 1, then A times 1, then T times 1, then D times 1. Just to make sure that I know what's going on. Then I can count 3 plus 1 plus 1 plus 1 plus 1 plus 1. Does that give me all the letters? Elevated.
Yeah.
8. Okay, good. Then after that, we proceed. Okay, I'm just going to copy this over to my solution. I'll send you the updated solution later. Okay, so what we realize is that we can actually it is still possible for us to arrange so that the vowels and the consonants are alternating. Just to make it look nicer, I'm going to use red color and blue color. Can see it's alternating.
Okay.
Yeah, so what's another way? What's another way?
Like start from L first.
That's the way I started with. Start with a consonant first, then after that.
Like put the E in front of the L.
Correct. Yes. You got it. So basically, I spelled elevated again. You see, it's elevated.
Ooh.
Okay, whatever. Not important. More important is to see the pattern. Blue, red, blue, red, blue, red, blue, red. Okay. Blue, red, blue, red, blue, red, blue, red. And then let me count carefully. Blue, red, blue, red, blue, red, blue, red. Then the next one is red, blue, red, blue, red, blue, red, blue. Okay. That's the 2 patterns. But then, of course, you know that the E's are repeating, so you need to be more careful when you're counting. These are your 2 cases, case 1 and case 2. So for case 1, how many ways? How many ways? Just like the boys and girls, the men and women example. How many ways? Focus on the blue one.
Times 4 factorial over 3 factorial.
Sorry, could you repeat that? I think your audio got cut off.
4 factorial times 4 factorial over 3 factorial.
Very good. So this first 4 factorial is for which one? The red or the blue?
The blue one.
The blue ones. Then this 4 factorial, why need to divide by 3 factorial?
Because the 3 E's are repeated.
Correct, exactly. Then now it is exactly the same for case 2. You just need to bracket times 2. That's your answer. Okay, let's see the answer. Did they do the same thing? Yes, they did the same thing. Oh, then you times 2. Okay, maybe I just copy down the two cases for you. Cut, bring it down, paste over here. Why times 2? Why times 2 is because there are two of these possibilities. What we are doing is number ways. Okay, I'm just gonna write down 2 times at the front. Number of ways arrange vowel consonants. Consonants are the ones that's not A, E, I, O, U. Then number of ways to arrange. I can't spell. Oh my goodness. ARRANGE. Arrange the vowels. Maybe just to color code it, I'll use red color. Blue color for vowels, red color for the consonants. Just to make it look nice. Okay, then yeah, that's how you get the 4 factorial, and this one 4 factorial over 3 factorial. Times 2 is because there are two cases. Okay. Can good. Now you learn alternating. Next, part 4, between any two E's. Okay, there must be at least 2 other letters. Oh, that sounds like E, then I need 2 letters. That sounds like a grouping. That sounds like a group. You must always keep the group together. Right?
Yeah.
Make sense? So I don't draw a box, very messy. I'll just draw underline. Like this. Okay, then in that case, how many groups would there be now? How many letters were there again? 1, 2, 3, 4, 5, 6, 7, 8 numbers. Letters, sorry. We already want to reserve 4 of them inside one group. So how many others are there?
4.
8 minus 4, 4 others, right? So 1, 2, 3, 4. So that means that we now have 1, I don't draw arrow. 1, a 2, a 3, a 4, a 5. 5 unique, I don't know, units or groups, depending on what you want to call it. I usually call them groups. 5 unique groups. How many ways to arrange 5 unique groups? Just ignore the fact that it's blank here. 5 factorial. Yeah, correct. But wait, now within the groups, you need to what do you call it? You have to consider how do you construct this group? 2 E's here, but how many E's do we actually have?
3.
3 E's. So that means that actually the E's, are they distinct? Does it really matter? Do we need to choose them? Letters, are they distinct? Like this is a E1, this is a E2, this is a E3. No one. They are all the same. Right? So that means we don't really need to go and do 3 choose 2 and then times 2 factorial. It doesn't matter. No. Because the E and the E here are non-distinguishable. This is not a man and a man. Man 1 and man 2 definitely are distinct. That's why you can arrange them man 2, man 1. So times 2 factorial. Here, we don't need to do that because the E are not distinguishable. Okay. So let's just lock in the E, whatever. Then we still got 2 blank space. That's more important. What can we how can we select these 2 letters?
2 factorial.
2 factorial is arranging, but we need to select the letters first. We don't even know what type of letter it is. So must have multiply by number ways to select 2 blanks, the 2 blanks. And then multiply by a number of ways to arrange those 2 blanks. Select and arrange. So let's think about it. How many ways can you select? We already have used up 2 of those E's, so how many do we have left? Minus 2, right? So that means your E, you only have 1. L, V, A, T, and D all only left 1.
I cannot choose the E, right?
Yes, correct. Because 2 other letters. So cannot be E again. So that means E is out. We only have how many choices? L, V, A, T, or D, which is how many choices?
5.
5 choices. We need 2 of them. So how many ways to select? From 5, we need to choose 2 of them to be inside. How many ways?
5 choose 2.
Yes, the answer is already revealed from the English. From 5 ways, you want to choose 2 of them to be inside. But then these letters, are they different or are they the same?
Different.
So what do you need to do? Can you arrange them? Yes. How many ways? Times
2 factorial.
2 factorial lor. Okay, good. So that is the answer already. Okay. First, you do grouping because of the condition. The moment you see must be sandwich in between, you know you need to form a group. Then after that, you count the number of distinct groups. Here's one group. There's a second. There's a third. There's a fourth. There's a fifth. Right? Then after that, then you arrange those unique groups, 5 factorial ways. Then after that, you consider, but then this one special group, we didn't consider how we constructed it. So there's still a few number of ways that we can construct it. So in that case, you have to be, it must be case by case already. If this was a case where it's men or women, we may need to move the E around. So it means we need to swap them around 2 ways, 2 factorial ways. But here the E is not distinguishable, so we just leave it. Just leave the E alone. Then after that, you consider this guy, the empty spaces, how many ways to arrange it. So sorry, to select first and then arrange it. If I choose 2 ways to select it, 2 factorial ways to arrange it. Based on this logic, where we cannot use a E again. The other 2 letters must be different from the E. So you must really read the question. It changes all the time. You have to read the question and understand. Go through the logic. Yeah, and that's it. I think that's the answer. Is it not? I hope it's the answer. Did I count wrongly? If I choose 2 times 2 factorial, maybe I counted too much. I think I might have counted too much. Let's see. Oh. Did I count? Did I overcount?
Um,
Let me see. All right. Let me think carefully. 1, 2, 3, 4, 5, 6. Okay, let me think a bit. Oh, sorry. I forgot. I forgot to consider what in my way of counting, right? I actually allowed my 5 unique groups to include the E inside, right?
yeah.
I mean, one of these positions is the third letter E, right?
Yeah.
Could be the E. What if it ends up over here?
Cannot.
What if it, then cannot, right? Because between 2 E. So I overcounted this case. So I need to find out the number of ways for this case and subtract away. Wow. That's a little bit difficult.
Yeah.
I guess. But if you really want to, you can go and count that number of ways. Let's just do it. Let's just try that. So we need to subtract away that particular case. Sorry, I didn't account for that. So we lock in the 3 E's already. So that means we only have 1, 2, 3, 4, and 5 other letters. 5 other blanks where we need to fill in with letters. Since we already locked in 3 E's, we are only left with the L, V, A, T, and E. 5 distinct letters to put in 5 distinct positions, which means that it's actually just 5 factorial, right?
Yeah.
So does that cover all the cases? No, there are still more overlapping cases. Okay, I'm so sorry. My method of counting got over counting. The E repeated. So I cannot do that. Let's just look at the solution. How did they do it? They just bash. They just consider all the possible ways, all the possible cases. They want to form a group such that any 2 E's must be at least 2 other letters. I also realized here there's a very sneaky word, at least. Sorry, I didn't see it. What does at least 2 mean? Can it just be 2? Or could it be anything else?
2 can.
2 can, but anything else? At least
3.
3. So I forgot to consider the case where it's E, 3 spaces in between, and then E again. Wow, that's getting quite complicated. Oh no. Then in that case, we should just look at the solution. Okay, I'm so sorry. Let's take a look at the solution.
Okay.
Okay. There are how many letters again? 8 letters. One elevated. 1, 2, 3, 4, 5, 6, 7, 8. Then case 1, they considered E here, then 2 blank space. But wait, there's a third E. There's a third E over here. So 2 blank spaces. And then you leave a blank space there. Okay? Can. In that case, there are only 5 other distinct letters. The LT, what is it? LV, T, and D. LV, T, D, and A. Right, the LV, T, D, and A. So there are 5 ways to slot into 5 positions. I mean 5 distinct letters to be sorted into 5 distinct blank spaces. So that means the number of ways is 5 factorial. Then any other ways? Maybe we can rearrange the E, move it to the right. So now there are 3 blank spaces. But what you realize is that there is also the other possibility. You move this E and this blank around. So it's 3 blank spaces and 2 blank spaces. And then you can also consider one last case. You have 2 blank space, 2 blank space, and 1 blank space here. The E is in between. Are there any other ways? I don't think so. Can we have 4 blank spaces in between? At least 2 means can consider 4, right? Can we have that? Remember, there are 8 letters. And in between any 2 E's, we cannot have E again. So E cannot appear here. Then where can E appear? 1, 2, 3, 4, 5, 6.
Outside.
Outside, right? It cannot be inside. So it's either E here or E on the left. Sorry. But that means that they will have a clash. So that means it's impossible. Is it okay? E here? Cannot. Or if it's E on the other side, cannot as well.
Then why cannot put one letter then E?
Sorry, what do you mean? Can you try drawing? What do you mean? One letter.
Because there's only 6 letters now.
Let me count. 1, 2, 3, 4, 5, 6, 7. There's only 6 letters here. Oh, we still need 2 more, right? Now I'm considering that there's only how many E's? Remember, there's only 3 letter E's, right? Now I'm considering what if we have 4 gaps in between?
Then E.
Oh, wait. Is that possible? Let me count. 1, 2, 3, 4, 5, 6, 7, 8. Let me think a little bit. That seems to work. Let's think a bit more carefully. Elevated. Let me bring down the letters. We need to actually look at the letters to be more precise. Okay. So you're considering what if you have a blank space here and then after that you put an E. Could that work? This one doesn't work. This one doesn't work. This one maybe. If we put 3 E's, then how many letters we have here left? 5. That's possible. Oh, I need more time to think about this. This is possible. Let me think about it. Is there anything else? Ah, right. Oh, sorry, not possible. Remember the condition was at least 2 letters in between any 2 E's.
Yeah.
How many blanks do we have here? 1 only. Is that at least 2? No. Sorry, yeah. Yes, correct. This is not possible. Okay, so basically, these are the only possibilities. You have to go and work it out. Then there are 4 only. Okay, so that's why each case will have 5 factorial. And since there are only 4 cases, just 4 times 5 factorial. Wow. Okay.
Okay.
And this one just logic casework. Okay, next. 17, what happened? 16 is fine. Part 3, part 4. 17, part 1 is okay. Part 2 is not okay. Let's just take a look. A rectangular shed with a door at each end contains 10 fixed concrete bags marked A to J, fixed 5 on each side. 10 canisters, each containing a different chemical, are placed with 1 canister on each base. Okay, so there are 10 boxes A to J, and there are also 10 canisters to be placed on those bases. In how many different ways can the canisters be placed on the bases? That's just 10 factorial, is it not? Oh, wait, hold on. You have to be a bit more precise than that. Because, wait, actually, that's correct. Yeah, 10 factorial. Okay, it's quite simple. You didn't answer that question. There was a hidden part 0. 10 factorial. Do you see that?
Oh, yeah.
Yeah, okay, quite simple. You understand how you get 10 factorial?
Yeah.
Yes, okay, can. Then how about part 1? Was it okay? Part 1 is okay. What's the question asking? Find number of ways in which the canisters can be placed in 2 particular canisters must not be placed on any of the 4 bases A, E, F, J. A, E, F, J. And next to a door. And J next to a door. Okay, the next to a door is not important. So basically, you cannot put on A, cannot put on E, cannot put on F, cannot put on J. Then you want to consider the number of ways. Let's read the solution first for part 1. You got it right, huh? For part 1. Is it?
Yeah. I need.
Okay, let me read the solution. Method 1, you have to consider the 2 particular canisters first. You take 6, choose 2. Then you arrange them 2 factorial. And then the other canisters, you only have 10 minus 2 left. So 8 factorial ways to arrange them. This is the number of ways. Then after that, you just take 10 factorial, subtract away, and you'll get the answer. It's just the complement. Okay, I think method 1 is the easiest to understand. Method 2 and 3. I will skip it. Let me know if you want me to go through. Okay. Do you want me to go through? If not, we skip first because part 1 is correct already.
Yeah, okay, can skip.
Move to part 2 first. Yeah, part 2. So now, let's read the question. If 2 particular canisters must not be placed next to each other on the same side of the shed. 2 particular canisters must not be placed next to each other on the same side of the shed. Okay. Hold on a second. Let me see. Right. Sorry. I realized something. Part 1, this is the answer. It stops here. Oh, yeah, it stops here. 1209600. Let me see your solution first. This is correct. For part 2, very simple. You just have to take the complement method. The total number of ways is 10 factorial. In part 1, we have already found out the number of ways such that 2 particular canisters, they are not placed on the 4 corners. Then here part 2, we're considering if two particular canisters must not be placed next to each other on the same side of the shirt. I think it's just a complement, right? Is it not? Oh, no. Sorry, let me think a little bit. Let me check first. Was there a typo in the solution? It feels like it should be 8 choose 2. Okay. Oh, okay. All right. Okay, let's draw out the box first. Actually, I can just copy this. Okay, so here's the shed, and we have all these bases. Then what happens is that you have two particular canisters. They cannot be side by side. They are enemies. Cannot be side by side. So if you put A and B, it's not possible. Put A and F, maybe possible. B and C cannot. Actually, let me just double confirm. Can A and F be possible? Cannot be placed next to each other on the same side of the shed. Okay, so it's still possible. If you put A and F, it's possible. B and G, possible. C and H, possible. D, I, possible. E, J, possible. So let's consider the number of ways. Here, it will be good if we just count the number of ways such that they are beside each other. Okay? Does it make sense? We're counting number of ways such that the two are never beside each other. So we're going to use the complement method. We're going to take total number of ways minus away number of ways where the opposite of what they want, which is two particular are side by side. We purposely put them side by side. Then we count the number of ways. Then we take total minus away that number. Does it make sense?
Yeah.
Two particular canisters. Two particular canisters are side by side. So how many ways can we do that? Here, let's read the solution. Choose the positions for the two canisters. Okay, can. So how many ways can we choose two canisters that are side by side? 3, 4, 5, 6, 7, 8. Make sense? 8. Okay. So total we already know is 10 factorial, right? Because there are 10 canisters and 10 boxes. So total number of ways is just 10 factorial. The part that you forgot to answer at the very, very beginning, then you minus away bracket. We already know that there are 8 possible pairs already. 1, 2, 3, 4, 5, 6, 7, 8 possible positions.
A and F cannot.
Sorry?
Like A and F cannot.
A and F cannot? What do you mean? Oh, like this?
Yeah.
Let me think. No. We're trying to. No, cannot. I think that's not side by side. Well, now we are doing the opposite. We are doing the complement method. Do you understand that?
Yeah.
Then when we are considering the opposite of no two are side by side, it means that those two are side by side on the same side of the shed. Okay, let's read the English. Must not be placed. So opposite of not means is placed next to each other on the same side of the shed. I think they are that if A and F, you choose A and F, I don't think that's part of the cases. No.
Okay.
Because it's not on the same side of the shed, they're on opposite sides. So it's not relevant. That means we should just consider those 8 pairs. 1, 2, 3, 4, 5, 6, 7, 8. Here they wrote down 8 choose 1, but I think it's quite simple. You can just manually count the 8 ways. Okay? Then 8 ways. We have chosen their positions, but how many ways can we arrange them? If let's say we chose C and D, within C and D, there's a canister number 1, canister number 2. Are they distinguishable? Or are they duplicates?
Distinct.
Distinct. So that means we can arrange them within the chosen C and D position. Can be one on the left, one on the right, or one on the right, one on the left, which means there are 2 factorial ways to arrange them. Okay, good. So now after we have chosen, locked in those 2, we have still 8 other canisters. How do we get 8? 10 minus 2. What do we do with those 8 canisters? We arrange them. 8 factorial. Okay, that's it. That's the answer. So this one I'll just label is to select positions. So position of the 2 canisters. This one is to arrange those 2 canisters. Particular.
Why the select position is times 8?
1, 2, 3, 4, 5, 6, 7, 8. You can either put it at A and B. That's one way. Or B and C. That's the second way. C and D. Third way. Do you get it now? D and E. Fourth way. Or F and G. How many did I count already? Fifth way. G and H. Sixth way. H and I. Seventh way. I and J. Eighth way.
8 choose like 1.
Sorry?
Is it like 8 choose 1?
Yes, correct. Yeah, essentially. That's the 8 choose 1.
Okay.
But honestly, that logic, why do they 8 choose 1? I don't really get it. I just understand that you can manually count it, and it's not too bad. Right? When you have 5 in one side, there are only 4 possible pairs. 1, 2, 3, 4. Then the other side will also have 4. So 4 plus 4, 8. 8 ways to pair them up. Is it okay?
Yeah. Okay.
Then arrange those 2 particular canisters, and then finally you arrange. See, we don't need to select the other canisters already, right? Because they are locked in. You only have 8 more. No need to select. So you just arrange others. 8 others. How do you get 8 others? Because already 2 particulars, so 10 minus those 2 particulars. No need to select. No need to select those 8. They are locked in already. Those are the only canisters we have left. You don't need to select them. If you want, you can do 8 choose 8, which is just one way. If you really wanted to follow the pattern, select then arrange. So times 8 choose 8. I'll select those other canisters. But a bit redundant. You don't really need this. Okay. Is it clear now?
Yeah. Okay.
Okay, good. Okay, done. Now move on to probability. Let's see. Hold on a second. Okay, probability. I need to find the worksheet. Sorry, give me some time to find the worksheet. Yeah. Okay, let's take a look. Which one do you get wrong? 2 part 2. Okay, let's see. Oh, wrong worksheet. Hold on. Okay, let's read the question. So a fair six-sided die is thrown 2 times. A, B, and C are defined as the following. A is the total score. A is the total score is an odd number. B is the event where a 6 appears at the first row. C is the event where the total score is 10. For part 1, you calculate P of A intersect B, state with a reason whether A and B are mutually exclusive events. They are not mutually exclusive because the probability of A intersect B is not 0. Okay. Do you get that? Yes, you got that. Okay, good. So, okay, let's just, and A intersect B is just 6-1, 6-3, or 6-5. Yeah, okay, correct. Then for part 2, we want to calculate P of C and P of C given B and state whether B and C are independent events. Total score is 10. Okay, here I would actually recommend that you draw a table. Whenever they give you thrown twice, this means that you can very easily construct a table. So over here we got what? We got P of C, which means total score is 10. Total score means you can construct a table as like the following. Okay. Draw a table like this. Then label 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's the results for every single throw. I think it's worth the investment in time. I know it's a bit slow, but I feel that it's very useful. Then we're gonna get a total score, so we're gonna plus add them together. Here, how many possibilities would there be? Can you tell me what's the total number of possibilities for the sum? This is die number 1, this is die number 2. Can be 1 with 1. Can be 1 and 2, or 2 and 1. Can be 3 and 1. Can be 4 and 1. Can be 5 and 1. Can be 6 and 1. Can be 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2. Or 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 3. So on and so forth. So what's the total number of ways? How many possible dots? Huh?
36.
Sorry? 36. Yes, 6 times 6, 36. That's the answer I'm looking for. Okay, good. So you can just draw in those 36 dots if you want to remind you that there are 36. Not too slow. It's not that's doesn't take that much time. Okay, then what we want now is total score is 10. So let's consider. Can you think of one way that you can get a total score of 10? Can 1, 1 work? No, a bit too small. How about 2, 2? 2 plus 2 is 4. A bit small, still cannot. 3 plus 3? Cannot, 6 only. So we just keep on going. 4, 4, 5, 5. 5, 5 can, right? Do you see that? 5 plus 5?
Yeah.
So we put a tick here. Put a tick here. Do a bit of mental sums. If you want, you can write down. You can go and manually go and list down all the numbers. That is also not too bad. But here I'll just take a shortcut. I'll write down a 10 here. Then any other ways to get a 10?
6 and 4.
6 and 4 over here. 2 ways. 6, 4 or 4, 6. Okay. So there are 3 possibilities out of 36 possibilities. The number of favorable outcomes is 3. That's your event C. Sum is total score is 10 divided by the total number of outcomes 36. So that's your probability. 3 out of 36. 112. Okay? Just list them down. It's very systematic. It will make sure you don't okay, if you want, you can also list down all the sums. 1 plus 1 is 2, 1 plus 2 is 3. But just to save time, I'm not going to do that. You can do the following, what I did here to get your P of C. Then how about P of C given B? You must remember the formula, okay? P of C given B is just P of C intersect B, then P of the bottom guy, the right guy, given condition B. Okay? Left intersect right, then divide by P of the right guy. Always this same formula. Is it clear?
Yeah.
Is it clear? Okay, good. Then after that, you know that it's an intersection, then divide by the given condition. This is called the given condition. Over here and there. Then we just need to consider what is those cases logically. So C intersect B. What is C? Total score is 10. What is B? 6 appears at the first row. So that means it's either what are the possibilities? C total score is 10, so there's only 3 possibilities. Then C, and then intersect with B. B means you want a 6 appear at the first row. So that means that we have only this possibility. You see that? This is the only possibility where the number 1 dice gives you a 6 and your total is a 10. Is that clear?
Yeah. Okay.
So that means there's only 1 out of 36 possibilities. That's why the numerator here is actually just 1 out of 36. One out of 36 on the numerator. Then you divide by P of B. P of B is what? P of B is the event where a 6 appears at the first row. So how many possibilities are there? 6 appear at the first row. Number 1 is a 6. How many possibilities? Count the number of dots.
6.
6 out of a total of 36 possibilities. So that means your probability at the bottom is 6 over 36. Can you see how you can just use the table to read out the answer? Is it clear?
Yeah.
Just
Okay.
count only. You see, number 1, the first die is 6. Okay, are you confused because you see the dots and you're confused? Do you need me to write down the actual numbers?
No, it's okay.
Okay. Yeah, so this is what we call a dot diagram. It's very, very useful for a situation where you throw 2 dice. Doesn't have to be a 6-sided die. Sometimes could be a tetrahedral die. Then you have like 4 sides only. So 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6. So there's only 24 possibilities, 4 times 6. But you need to read the question carefully. Yeah, so how about what about this part here? Why are they multiplying? Why they take 1, 6 times 1, 6? The reason is they know that C and B are independent events.
But the question never say.
They never say, right? So how do we know for sure? Actually, they are trying to prove it. So, this part, when they use 1, 6 and 1, 6, they're sort of assuming that they're independent already. Because the formula here is P of C intersect with B is equals to P of C times P of B. If it's independent. Then what is P of C is 1, 6. What's P of B is 1, 6. That's how they got this answer. So maybe the answer is not so good. The best way is to just count it. 1 out of 36, right? It's direct. It's just from the table. Then divide by 6 over 36, which is 1, 6. Then finally you will get your final answer 1, 6. Then how do you show that this is independent events? You need to show either one of 3 things. B and C are independent events means probability of B intersect C equals to PB times PC. Just multiply. Or P of B given C. You don't care about the given condition C. B is itself. So P of B on its own. Likewise, the other case where you have P of C given B, the given condition is B. You ignore the condition. You focus only on C. So it's equal to P of C. You show at least one of these 3 is true, then you are able to conclude that B and C are independent events. Okay, at least one. Don't need to show more than one. Save time. Just one is good enough. Usually you go for the first one. But here where they already told us to find C given B, right? That means we probably will be using the third one. Is that clear?
Yeah.
Okay. So P of C given B, our goal is to show that it's equal to P of C. Well, it's clearly not equal. We already calculated P of C, it's 1 over 12. We also calculated P of C given B, it's 1 over 6. They are not equal, right?
Yeah.
If they are not equal, then we conclude not independent. Clear?
Yeah.
Okay, good. So now what is this? P of A prime intersect B prime. They tell you it's 1 minus P of A union B. Do you get what's going on here?
Not really.
Okay, recap on Venn diagram. Let me show you. Okay, I'll just do a quick recap on Venn diagram. Where can I put this? I'll just squeeze it over here. It's in the probability tutorial. Okay, this is known as the, did I get it right? Let me see. Oh, wrong direction. Let's call this set A, set B, and set C. Can you see that there are 8 distinct regions here? 1, 2, 3, 4, 5, 6, 7, and 8. Mickey Mouse.
Yeah.
Can Okay, let's consider, I'll do an exercise with you to recap on your union and intersection logic and complement. A prime, B prime, so on and so forth. Let's consider, what is the region A? How many numbers do you see? What's inside A? I can see 1, 2, 4, and 5, right? So I write that down, 1, 2, 4, 5. How about B? 2,
Also 4.
3. No, list them down. List down the numbers.
Oh, 5, 6.
Good. How about C?
4, 5, 6, 7.
Very good. Okay, so what is let's consider, what is A union B? Oh, don't. What is A intersect B?
2 and 5.
2 and 5. Very good. Then what is C? C is that. So what is A intersect B union with C? In terms of the numbers. A intersect B in union C means you can read from left to right. A intersect B first, which is 2 and 5. Also, just to remind yourself, it's 2 and 5, it's already on top. Then you union with C. Do you remember what's union?
Like together.
Together, right? So A and B is 2, 5 already. Okay, good. Then after that, C is what? 4, 5, 6, 7, right? C is 4, 5, 6, 7. But what's so special about sets? Can we have duplicates? Can we have duplicates? The 5 repeated? Cannot. I forgot already. Oh no. No duplicates allowed. That's the one of the main ideas. Cannot have duplicates allowed. So therefore, your final answer will just be region 2, 4, 5, 6, 7. This is really not, this will not be given any marks during exam. This is just to help students to know what is this region. So can you shade in for me this region here? A intersect B union C. There's a 2, there's a 5, there's a 4, there's a 6, there's a 7. Then you just fill in the blanks accordingly, like coloring book, If you've done the continue. Yes, correct. So this is called the middle finger trick. Okay, so why? Because this is just okay, I'll just shade it in. So basically, this idea of labeling all the numbers is for beginners who are struggling with identifying union and intersection. Okay. And you can do something similar over here. They tell you that A prime intersect B prime. Straight away, when you're given 2 sets, right, draw a Venn diagram at the side. Draw a circle A, a circle B, and they must overlap. Okay, we don't know whether they are disjoint, meaning they don't overlap, or not, meaning they do overlap. We always assume they overlap in general. So, but if it doesn't, it's okay. You can just leave it blank. Some students, they go and draw for me like this, set A and then set B. They try to draw like an enzyme and substrate. No. We are not doing bio here. Just draw 2 circles. Just draw 2 circles and they overlap. Can already. Clear? How to draw a Venn diagram? Okay, good. Then what's A prime intersect B prime? Let's study what's let's do the same trick again as the middle finger. So what's the first step? Label all the parts. I think you can see there are 4 parts, right? 1, 2, 3, 4.
Yeah.
So what is A? The numbers. What is B?
2 and 3.
So what is A prime?
3 and 4.
What is B prime?
1 and 4.
So what is A prime intersect B prime now?
4.
Just region 4. So that means that A prime intersect B prime is this region 4. Right? Then you want to find the probability of this region. How do you do that?
Like find everything.
the total area, which is actually just one. This is the sample space. So this total area is actually just one, but you have to minus away the unshaded region, right?
Yeah.
Which is 1, 2, 3. Make a good guess. How do you get 1, 2, 3? It's just set A and set B. What's the operation? Union or intersect?
Union minus the intersect.
No. Sorry, wait. Sorry, you are thinking of P of A union B equals to P of A plus P of B minus P of A intersect B formula, is it?
Yeah.
Okay, this is the intersection union formula. What I wanted to ask you is to just tell me it's union. Okay, when we say union, we're just referring to this region 1, 2, and 3, right?
Yeah.
A union B. Okay, maybe we slow down a bit. I ask you first. Toss this aside. What is A union B in terms of the numbers?
1, 2, 3.
1, 2, 3. Then in this case, can you tell me what would you get if you take the total S, then you take away A union B? This symbol here means take away. S is what?
1.
No, 1, 2, 3, 4. It's everything. Can you see? The set S is sample space. It's the whole region. 1, 2, 3, and 4.
Yeah.
Then S, if you take away A union B, what are you left with? You're left with just 4, which is the same, right? Can you see?
Yeah.
Can you see that? So A prime intersect B prime is the same as taking the S, the entire rectangle, take away A union B. Okay, good. So now that you know this, you can convert this into probability. Okay, I should write this down. A prime intersect B prime is really just S take away A union B. Then if you try to find probability, it will just be probability of this guy, which is probability of S minus away probability of A union B. But what's probability of S? It's just 1. Right? The total probability. Just complement method. Then you just take 1 minus P of A union B. Is it clearer now? This is set minus. Did you know this? Like, for example, like all real numbers but remove a 0. Like the domain functions notation. Do you know this?
No.
Like, no. Oh no. Okay. Like if you have f of x equals to 1 over x. Or if they like to use the fancy notation is f dot dot x map onto 1 over x. Then the domain is over here. Right? You cannot have 0 because if you end up dividing by 0.
So I can use in the exam.
Yes. This notation. Yeah, you need to know slash.
Okay.
Yeah, slash means set minus. Remove away the 0. Okay. Yeah. So that's how you get this part here. Is it okay now? 1 minus P of A union B?
Yeah, but do I like just memorize it?
I mean, if you want to, but best to use some logic. Just draw the picture. A prime intersect B prime is where? Green color region. Then I think from there is very obvious.
Okay.
Rectangle minus away union. But then what's union? This one need to memorize. P of A plus P of B minus P of A intersect B. Oh yeah, have you seen my video for A union B union C?
Yeah.
Okay, that's what. Huh?
Did you just upload it?
No, I sent it to you last week.
Oh, then I think I watched already.
Okay. Yeah, A union B union C. Yeah, I sent it as part of the homework. 1, 2, 3, 4. And oh yeah, have you watched those playlists that I sent you already? Discrete random variable, binomial. I didn't make those videos. Yeah, those are very good videos. I go and watch. It's been there for years. It's super good. The explanation. Okay. So A union B, right, is really just A plus B, then minus away A intersect B because of the 1 overlap. So then you can now fill in the blank. So what is P? But make sure you got a pair of brackets here. Or 1 minus pair of brackets. Then P of A is half, P of B is 1/6, P of A intersect B is 1/12. How do you get those numbers? We must look at the event again. What is event A? Total score is an odd number. How do we get odd number? When we take even plus odd. Right? So
Yeah.
you realize, wow, you see, you have to go back to the table again and you have to calculate one by one. So wouldn't it be easier? I'm sorry, I have to do it. I have to do it. Wouldn't it be easier if we just calculate each one manually?
Yeah.
Easy. It's very fast as well. Can you see the pattern? 3, 4, 5, 6, 7, 8. 4,
Yeah.
5, 6, 7, 8, 9. Very fast. Just do it quickly. I think it's the most bull-headed, don't need to think bulldozer method already. Don't need to think on. You just have to do it. And I think that's actually better during exam because you don't have too much time to think during exam. Very stressed. Yeah, so 7, 8, 9, 10, 11, 12. Okay, good. Then now you can start counting now. What is P of A again? Total score is an odd number, right? 5 plus 2 gives you 7. That's an odd number. Hey, that's another odd number, odd number, odd number, odd number. Then from here, you can just manually count. How many odd numbers? Here are odd, here are odd, here are odd, here's odd, here is odd. Count for me. How many?
18,
18. Then 18 out of what's the total number of possibilities?
36.
18 out of 36. Oh? That's how you get a half. Convincing?
Yeah.
I hope so. Just manually count only. Secondary school kid could do this. Just have to be careful with the counting. Then how about 1, 6? What is P of B? P of B, did we calculate already? I haven't. Okay, no choice. Must count. 6 appears at the first row. Oh wait, actually we did. Quite obvious. 6 appears at the first row. Number 1 die. So you look at number 6 column. This guy. How many possibilities? 6. Out of how many? 36. So what's the probability now? Number of favorable divided by number of total outcomes. So 6 over 36.
6.
Yeah, 6 over 36.
Yeah.
1 over 6. Then how about this last guy? P of A intersect B. We already calculated just now. 112. Okay. Yeah, then you just sub in and you get the answer. Can? Okay, Ken. Moving on. Next one. Let's see which is the next one you need help with. Oh, part 3, actually, you got it. Oops. Let's move on. Yeah, I drew a table. Good. Is it this? You zigzag. Can understand?
I do corrections. Then okay.
Can already, y'all.
Yeah, but must draw the diagram in the exam lah. Is it?
It will not be marked, but it will help you.
Okay, can.
It will help you. And this one part V, something wrong. Question mark, question mark. Okay. And you read the question. Question 7. Let's see. For events A and B, it is given that P of A is 0.7, P of B is 0.6, P of A given B prime equals 0.8. Find P of A intersect B prime. So part 1 okay, right?
Yeah, can.
Part 1 okay. Part 2 also okay. What was the part that was a problem? Part 5 onwards. Okay. Let me just see. Part 1 you find this, part 2 you find this, part 3 you find this. Third event C given P of C equals 0.5, A and C are independent. Then you can find P of A prime intersect C. For part V, hence state an inequality satisfied by P of A prime intersect B prime intersect C in the form of little p less than equal to that probability less than equal Q, where P and Q are constants to be determined. Use a Venn diagram to solve quickly. Let's see. Okay. Whenever you intersect, right, the probability gets smaller or equal to. Do you agree with this statement?
Intersect.
You see, from A, you evolve into A intersect B. When you intersect, what happens to your region? It becomes smaller, right?
Yeah.
So every time you intersect, the area becomes smaller, which means your probability should also become
smaller.
That's why we have a less than or equal symbol here to represent the idea. How about if I now have P of A intersect B intersect C? It will become even smaller or equal, right? It cannot be bigger, right? Intersect.
Yeah.
intersect the region, how can it suddenly become bigger? The only way you can be bigger is if you take union. So if it's purely just intersecting, the probability will get smaller and smaller and smaller. So likewise over here, what they did is they start off with this guy. The probability which we are interested in, A prime intersect B intersect C, is actually smaller than or equals to P of A prime intersect C. Do you see that? From here to here, you are introducing an intersect B. So that's why your probability gets smaller. Okay?
Yeah.
Then why do you want to relate to this guy? Because we already found out the answer from part 4, 0.15. Can huh? Okay, good. Why did they think of that? I also don't know, but it works. It makes sense, right?
Yeah.
Okay. Then now note that this guy, if you try to break it down, intersect B, and then you add on P of A prime intersect C intersect B prime, it will just be equals to P of A prime intersect C. Oh, what does that mean? It means if I can just draw a diagram quickly, here's A, here's B and C. Oh. Where is A prime intersect B prime intersect C? B prime intersect C is here. Where's A prime? A prime is everywhere that's outside of A. So that means that if I don't use my the middle finger trick, it's really just which region? This region, right? Can you see? Is that too fast? B prime intersect C is this part here, right?
Yeah.
Then A prime intersect with that region. We do it. I think we do it step by step. 1, 2. I use a different color. Oops. 1, 2, 3, 4, 5, 6, 7, 8. So you will see the value of using the middle finger rule already. 1, 2, 3, 4, 5, 6, 7, 8. Of course, if you can always do it immediately. What is B intersect C?
The 3 and 6.
3 and 6. Okay, good. Maybe I just increase the thickness in case you cannot see. Yeah. Okay, then that's 3 and 6. Then how about A prime? What's A prime?
Like 5, 7.
Think carefully. What is A first? 1, 2, 3, 4.
1, 2, 3, 4.
So A prime will be
5, 6, 7, 8.
very good. You skip the 6. I'm very concerned. You cannot see. Not 1, 2, 3, 4. It's 5, 6, 7. Yeah. Must include 6. Okay, then in that case, what is A prime intersect with B prime? Sorry, intersect with B intersect C. Intersect. 3, 6, 5, 6, 7, 8. Overlap is?
6.
So it's just 6. Do you get why I shaded this region now? Just now at the beginning?
So I split it up into 2. I do the B intersect C first, then I do intersect A prime.
Correct. Yeah. Yes. Or you could do A prime intersect B first and then intersect. No, order doesn't matter.
Okay, can.
Yeah, because they're all intersect. It's like addition. Sorry, it's like multiplication. The order doesn't matter. You can do the back one, then the first one, or you can do the first pair and then the back one, and then the last pair. Okay, so now here what I'm telling you is when you take the A prime intersect with C, then you intersect with B. A prime intersect C, but you intersect with B prime, you'll just get back to A prime intersect C. Does it make sense to you?
Yeah.
Okay, so yeah, that means that we can now, okay, A prime intersect C. Let me just shade it in. A prime intersect C in, let's say, blue color. I hope you can see that it's actually just this region here.
Yeah.
Then we are saying if you intersect with B, which is region number 6, this is actually number 6. Then A prime intersect C, which is your blue color, 6 and 7, intersect with B prime. What's B prime? What's B prime? Let's write this down. B is 2, 3, 5, 6.
The 1, 4, 7, 8.
Okay. So now if you want A prime intersect C intersect with B prime, what's A prime intersect C again? It's 6 and 7. So 6 and 7 intersect with 1, 4, 7, 8. What's the overlap?
6 and 7.
There's a 6, man. We're looking at B prime. Okay, is it too fast? Maybe I slow it down a bit. What's A prime intersect C first? We know A prime is 5, 6, 7, 8. But what is C? C is just 3, 4, 6, 7. Then A prime and C intersect. What do you get?
No, 6 and 7.
6 and 7. Okay, good. Then now I'm asking you, A prime intersect C, which is your 6 and 7, intersect with B prime, which is your 1, 4, 7, 8.
Oh, so it's just 7.
What's the overlap? It's just 7. Okay, good. So it's just 7. So now we have probability of region number 6 plus probability of region number 7 equals to probability of A prime intersect C, which is 6 and 7. Is it clearer now? Convinced?
Yeah, can.
Region 6 plus region 7 equals to the intersection, which is 6 and 7. Okay, so why do we want to do that? Because we know that this probability is less than or equals to P of A prime intersect B prime as well, which means that okay, this part is because we are getting rid of the intersect C. Then that, because when you intersect it becomes smaller, that's how you get this inequality. But this right hand side inequality, we already figured out the probability, right? That's why we want to use it. We already figured out the probability from where? From actually no, we didn't figure out the probability, sorry. But we figured out the formula for it from a previous question. It's 1 minus P of A union B. Then you can substitute A union B with the probability 0.92. Okay. Where did 0.92 come from? From here, from part 2. Okay, good. Then after that, you subtract, you get 0.08. Then that's our upper bound already. That's our Q. You see?
Yeah.
Sorry, actually, is that C? No, that's B prime. That's B prime. It's different from what we are looking for. B itself.
Oh.
No, that's not upper bound. Sorry, this is not Q. This is not Q yet. This is not Q. We need to go a bit further. So here we realize that, let's read the question again. What do we actually want? What do we actually want? Okay, we want to have an inequality for P of A prime intersect B intersect C. So this B prime here shouldn't be there, but it will be helpful later. Why? Because here, let's consider the actual probability we want. A prime intersect B intersect C. Now, when you intersect, the order doesn't matter. It's what we call commutative. You can actually swap them around. So the C and the B you swap around. Okay, that's what we're going to do. This is exactly equal to A prime intersect C, then intersect B. Swap the B and C around. Then as a result, we get this guy, which can be reinterpreted as intersecting A prime with C first, then after that intersect with B. Okay?
Yeah.
Can? Then wait, we already know the formula for this. We already derived it just now. We have a region number, this is region number 6 plus probability of region number 6 plus probability of region number 7 gives you 0.15. But this guy here is just region number 6. This guy, region number 6. Let me show the Venn diagram as well. Okay?
Yeah.
Then we can just bring this guy over. So 0.15 minus away the probability of region number 7. Okay? So this is number 7. But what's the probability of this region number 7? A prime intersect C intersect B prime.
The 0.
They are the same, 0.08. Because you see, intersect and intersect, you can swap the order. So now they swap the order again. C and B prime, they swap it around to get B prime C. So they are equal. This and this are the same.
So it's always commutative.
Yes. The whenever you have all purely intersection or all purely union, it's commutative. Like A union B union C, you can rewrite as A union, all three factorial ways are 6 ways. A union C union B, or B union A union C, and so on and so forth. You get the pattern, right?
Yeah.
I'll just list them down since I'm already almost there. C union B union A. Oh, of course, if you change it to all intersect, it also works. Okay, can but must all be the same. Then you can have commutativity, can swap them around. So over here, we can just subtract away the 0.08 and finally we get our 0.07. Okay, can? Then in that case, we will have now our lower bound 0.07 and upper bound 0.15, which we calculated from before. Here and here. Okay?
Yeah.
Can you replicate this during exam?
I don't think so.
Yeah, a bit difficult, huh? Yeah, I think this is very precise. Is there a simpler way to do this? I think the simplest way is to look at your Venn diagram. Okay, then you look at the event that we are interested in. A prime intersect B intersect C. A prime intersect B intersect C, which is region number 6, right?
Yeah.
Then we need to realize that region number 6 is smaller compared to region number, I don't know, 3, 4, 6, 7, event C, and it is bigger than or equal to region number 6 and 7, but you take away region 6. Okay, does it make sense? I don't think it makes sense. How to do it in a faster way? Well, you don't really have much of a choice. You need to go and look at the probabilities that were given beforehand, and then you compare and contrast. Not easy, not easy this question.
Yeah. Okay.
Compare those. Okay, let's just move on. Okay.
Yeah.
Okay, let's take a look at. Is it part? No, question 8. Okay, all right, good. Tree diagram, good. Whoa, you asked a question. Why does the formula work when question did not state independent? It did not work for subsequent questions. Oh, let's see. What is the question asking first? Question 9.
Yeah, that one I don't know. Like, am I supposed to like understand that it's independent? What's the question
No.
say?
Yeah, they didn't say. Made by A and is 40. Okay. Camera lenses are made by two companies, A and B. 60% of all lenses are made by A, remaining 40% by B. So you can get 0.6 and 0.4 here. That's fine. Then 5% of the lenses made by A are 40, so 0.05. And then the other one is just 1 minus 0.05, 0.95. Then 7% of the lenses made by B this time are 40, so 0.07 and 0.93. Okay, can. Then, which was the one you got wrong again? Let me read. This is part 2. Oh, your labeling a bit funny. Is this part 1, part A?
Yeah.
Or is this one part 2, part A? This one is part 2, part B, is it?
That's the second question.
Here, part 1, part 1, part A. Part 1, part B.
Part 1, part B.
Which one is this one? Is part 1, part B? Wait, what? Huh?
No, the one that I wrote the question is part 1, part B.
Okay. can label correctly. So part 1, part B, made by A, given it is 40. So in this case, you need to understand that this is just P of A, then this is P of A prime, or 1 minus P of A. Okay, then over here, this will be P of, this is F by A, so I'll just call it 40A. Given A. Given A made the lens. This guy will be P of not 40A. So I'll write down 40A, but then I'll put a tilde above the 40. So that tilde there is just telling me it's not 40. Given that it was made by company A, brand A. Then this 0.07 is P of 40 and made 40B, given that it's made by brand B. Okay, maybe I don't need to mention the brand now, since it's already mentioned by the given condition. Just 40 or not 40. 40 given that it's made by B, then the other one will be not 40. Oh, not 40 given that it's made by B. Okay, it's a conditional probability from the second level branch onwards. Then over here, if you try to multiply these two, you'll just end up with P of A times P of, given that you, it is 40 given that it was made by A. Then from here, you know the formula. 40 given that it's A means it's 40 and made by A, made by brand A, divided by probability that it was made by A. These will cancel off, which will give you the intersection, probability that it is 40 and it is made by A. So over here, when you multiply these two branches together, you're actually multiplying a probability of A with a conditional probability. Then using the formula and formula again, they cancel off, you're left with the intersection. You did not use the idea of independence. These two events are not independent. We did not assume that. When you don't need to assume that when you're multiplying.
Oh, so for the tree diagram, the second branch onwards is always conditional.
Yes, correct. I think I mentioned that very, very hurriedly when I was talking about the proof notes. Remember? I sent you this already? Have I sent you?
Yeah. Sent already.
Over here, right? This very, very tiny diagram. Need to zoom in a bit. Sorry. Conditional. Okay. Second branch onwards, second stage onwards is always conditional probability. B prime, given A, given A. Okay?
Okay.
Okay, good. Oops. Yeah, so let's read the solution lah. Part 2, part A. Probability that, is that what you were asking? Oh, sorry, part 1, part B, is it? Okay, this one, P of A given F, made by, given that it was made by A, sorry, probability that it was made by A given that it is 40. So P of A intersect F. Then you just have to find P of A given F. Then you just have to use the formula. We write it as P of A intersect F divided by P of F. But what is A intersect F? It's just this branch over here. So you can just multiply 0.6 times 0.05. You are not assuming independence here because you are just using formulas involving the probability A and conditional probability. So yeah, no independence here. Then you divide by P of F, which you calculated from before. Okay? Can now?
Okay.
Okay, good. Let's see. So no. No assumption of independence made. It's just conditional probability. Okay, and definitions. Okay, then the rest wrong. Question 10. Oh, it's a different question. Okay, then I'll just go through the rest. Okay, let's take a look first. So part 1, it is 40. You just have to calculate probability of this branch and this branch. So this plus this. Okay, you multiply and multiply. then you add them together. Okay, this is part 1, part A. It's fine. Part 1, part B is also fine. Now part 2, part A. Two lenses are selected at random. Find the probability that exactly one of them is faulty. So this is just conditional probability lah. Sorry, let me drink some water. Oh my goodness. Okay. Can. Where was I? Part 2, part A. Two lenses are selected at random. Find the probability that exactly one of them is faulty. So both are made by A and exactly 140. All right. Can. So we can just use conditional probability. Here, before that, we need to calculate the part 2, part A. Sorry. Exactly one of them is faulty. Yeah, I should deal with part A first. Two lenses are selected at random. Find the probability that part A, exactly one of them is faulty. So over here, they took 0.058, which is the probability that a lens is made by F. Multiply by 1 minus this, then times 2. What does it mean?
What's wrong with my working?
Oh, part 2, part A. Let me see first.
I thought like it made sense. Like I do like case by case. Like the first one is A, that's 40, and the second one is B, that's 40.
You have a 0.4 and a 0.93. Sorry, let me read the situation again. Two lenses are selected at random. So you want exactly one of them is 40. So it means you're considering A 40, B is not 40.
Yeah.
Or B 40, then A not 40. Add them together. Right?
Yeah.
Okay. Let's think about it. I better check your. Okay. Let me see. Oh, right. You might need to times 2. Does the order matter here? So okay, let me sorry. Let me explain what they did first. What they did over here is they used the answer from part 1, part A, where they got the probability that exactly one lens is 40. Right? So it's either AF or BF. Then in this case, they calculated that probability. They used that probability that was calculated at 0.058 multiplied by the probability that is not 40. So this is one exactly 140, and this is exactly one not 40. Okay, 140, one not 40. Then that is one case, but there's also not 40 and 40, the other way around. That's why they times 2, and they get this answer. Then you're arguing the other way. You're arguing, how about if we have lens A 40, lens B not 40? Multiply that, then you get lens A not 40, lens B 40. Does that work? It should work. It sounds right. Let me just double check this out, because their method definitely works. For yours, your okay, essentially if they when they did this, this translates into 0.6 times 0.05 plus 0.4 times 0.07. That is how they got 0.05. Then you multiply this by 1 minus that same thing. 1 minus the same thing. And then times 2. Versus your answer, which is 40, not for, sorry, 40, not 40, not 40, 40, which is 0.6 times 0.05, that's a 40A. Then you continue by multiplying with 0.4 and then 0.93. So you think of them as consecutive events. You selected a A that's 40 and select a B that's not 40. This is 0. Then after that, you have to consider the other case. So it's plus 0.6 times 0.95. A is not 40. And then after that, you select B, that is 40. Are they equal?
No.
Sorry, I forgot a pair of brackets here. Pair of brackets here, like this, and then square bracket. Yeah, they are not equal because I think if you try to think of them as consecutive events, it may not be so accurate. Oh, it may not be so accurate.
But I thought like in order for it to be exactly 1, then the other one must be not 40.
In order for what to be exactly 1?
Like in order for only one of it to be 40, that means the other one is not 40. So I like they must be like together.
Oh, I need to think about this. I'm not too sure. It seems to work. Unless you're missing a factor of 2. Let me just calculate the numerical value first. Okay, I have to get back to you on this one. For now, we follow the solution here because this makes more sense. Okay, can Okay, I'll get back to you on that one. Then for part B, let me just circle this. Okay, for part B, we have 2 lenses. Oh wait, sorry. 2 lenses are selected at random. Find the probability that both were made by A, given that exactly 1 is 40. Both were made by A, given that exactly 1 is 40. So that just means you have to use the conditional probability formula. Take these 2 conditions and AND them, A and D. So both lenses made by A and exactly 1 of them is 40, divide by probability of exactly 140. So this exactly 140 probability we already found from here, right? But can we can use that lor. So we will use that as our denominator, right? 2 times 0.058 times 1 minus 0.058. But the numerator, this one need to calculate on our own. Both lenses made by A exactly 140. So it means that must be 40 non-40 for A, or non-40 then 40. So that means is 0.6 times 0.05, that's for 40 lens. And then 0.6 times 0.95, that's for non-40 lens made by brand A. These 2 parts here. But then you have 2 lenses, so you times 2. Okay, can. Then you just divide them and you get the answer. Just key in the calculator. Okay,
Okay.
can. Then part 3. 10 lenses are selected at random. Find the probability that exactly 2 of them are 40. So over here, you can identify that it's a binomial probability, right? Binomial. No.
How to identify?
Uh,
Oh.
Binomial. You need 3 key ingredients. Number 1, n independent trials, where n is a fixed constant. Oh. Number 2, probability p is a fixed constant for each trial. For each successful trial. Sorry, maybe I should have mentioned this successful thing as number 2. This should be number 3. Number 2 is your random variable x can only have two outcomes, success or failure. And here, let's figure out what are those NP and the 2 outcomes. Oh, so N here is what? 10 lenses. Then what are the 2 outcomes? Probability that here exactly 2 is just telling you the random variable x equals 2. X representing number of lenses that are 40 out of 10 lenses. So here it means the outcome is either success, means it is a 40 lens, or failure is not a 40 lens. Since we already calculated the probability of exactly 1 lens being 40, I think we can use that probability, right? Yeah. So that's your p value. It's your 0.058 here. Okay, that's your p value for the successful outcome. Okay, so from there we can replace the n with a 10, replace the p with a 0.058. Okay, good. Then after that, we just need to find p of x equal to 2. Then it's just a binomial probability, which is telling you we want to have 2 success. In this case, a success is a 40 lens. A bit funny, but okay. So we have to have power 2. Then if we want out of 10 lens, 2 of them are a success. So we have 0.058 times itself, 2 times. But the ones that are not success means they are not 40. The probability will be 1 minus. And how many of those lenses are there? We start off with 10 of them. 2 of them are 40. So the other remaining one must be how many? Start with 10 lenses. 2 of them are 40. How many are non-40?
8.
And minus 2, 8. Then the probability is just you just assume that they are independent. Independent, that means you can multiply the probability. You can multiply the probability directly. Then you get how. That's why you have 2 copies of the success and 8 copies of the failure. Then you just have to multiply their corresponding probabilities, 2 times and 8 times. So wait, how many ways can we do it? If you select 10 of these lenses, you can actually mix them around in different orders, right? So how many ways to do that? It's actually 10 choose 2. And this is the binomial PDF formula. Okay. Success, and 8 failures. Or you could move them around in any other order. Then they will also contribute to a particular branch in the tree diagram. Then you just have to add them together. If you watch the video, you will be able to see a very clear explanation where they give you many examples, clearly drawn tree diagrams. Okay, I think that video explanation is very good. You can go and watch it.
Okay.
Yeah, then after that, that's your answer. You can key it in. So anyways, here's the answer. They got 0.0939. Okay. Okay, good. So I will get back to you on this part 2, part A, whether this other method that you suggested could it work as well. I cannot answer you straight away. I need to think about it. Okay, next. Sorry, I'll get back to you. I'll make a video for this. Okay, question 10. Question mark. Oh no. Why got dy dx? Not sure. Okay, let's just read the question first. How to identify its given formula? Okay. Can let's just start from the beginning. A company buys P% of its electronic components from supplier A and the remaining 100 minus P% from supplier B. The probability that a randomly chosen component supplied by A is 40 is 0.05. Probability that a randomly chosen component supplied by supplier B is 40 is 0.03. So you basically get this diagram. P%, then not P%. So 1 minus. 1 is really just 100%. 1 is 100%. So 100% minus P%. P% is P over 100. Then after that, branch A, after you have selected supplier A, he either provides a 40 or not 40 component. So 5% or 95%. 0.05, 0.95. And likewise for the supplier B, he said the question said 40 is 0.03. So it's 0.03 here, or the other branch which is 0.97. Now, given that P equals to 25, find the probability that a randomly chosen component is 40. Yeah, so over here, you just need to replace the P with 25. And then you'll be able to calculate the rest. But what did they do over here? They just straight away calculate P40 in terms of P. So let's calculate that. So what's the probability of it being 40? It must be this branch or this branch, right? Can you see?
Yeah, okay.
Yeah, then you just have to multiply P over 100 times 0.05, 1 minus P over 100 times 0.03. That's how they get this branch over here. This calculation here. Clear so far? For the first branch, you just multiply along the numbers along the branch. You get the P of A providing a 40, supplier A providing a 40 component. Then take this one times this one, you'll get the probability of B supplying a 40 component. B intersect F. This one is A intersect F. Is it okay?
Yeah, okay.
Okay, good. Then after that, you just have to sub in P equals to 25 and then you'll get your answer. Okay. Key this in the calculator, but replace the P with a 25. You get 0.035. Okay, good. So that first probability is done. Next, for a general value of P. So now the P is no longer 25, it's just a general value of P. Find the probability that a randomly chosen component that is 40 was supplied by A. Oh, sorry, not fine. The probability that a randomly chosen component that is 40 and is supplied by A is denoted by FP. So that means this particular branch is FP. Then you want to show that FP equals to this fraction. Okay, but actually this is a conditional probability, because you want it to be 40. That is 40 is a condition. So that means that we want to restrict ourselves to focusing on P of A given F. Okay, restrict ourselves to focusing on given that we guaranteed we'll have a 40 component. What's the probability that A is the guy who supplies that 40 component? Is this part okay?
Yeah, okay.
Then A intersect F will, A given F will just be A intersect F divided by P of F. P of A intersect F divided by P of F. But what is A intersect F? Is this branch here, which is the numerator, which will give us this numerator, P over 100 times 0.05. Is the numerator okay?
Yeah, okay.
Can write just A intersect F, just go along the branch. But then you have to divide by P of F. This is when you have to use the answer from before. Where do you get P of F from? Probability that you have a 40 component. Where do you get this from? It looks very familiar. Probability that a randomly chosen component is 40. Right from above. Can you see?
Okay.
So your answer is just using the answer from above, which is over here. This guy will be your P of F, which will go into your denominator. So that's why this part here will go into your denominator. And then after that, it's just a matter of simplifying the algebra to get to this guy. Okay? Let me show you how to simplify. You can times 100 over 100. That's okay. That's okay because 100 over 100 is just 1. So you multiply by 1, nothing happens. But why do I want to do that? It's because bracket. If I take my 100, I distribute. Sorry, do I need to distribute? Actually, I don't because it's a times. So I just have to multiply in one time. Notice that it will cancel off with the 100 over here. Can you see? 100 and 100 cancel. Then you're left with 0.05 times P. Is this part okay? The numerator? Just the numerator, is it okay?
Yeah. Okay.
Okay, then now the denominator, you have a plus sign. So there are two separate terms. You have 100, you have to distribute in. So 100 times P over 100 cancel off, you're left with P times 0.05. 100 times inside this second term, you have to be a bit more careful. Over here, I'm going to choose to multiply the 100 into this bracket here. So again, there are two separate terms. So I have to distribute the 100 into the two terms. So 1 times 100 minus away P over 100 times 100, which will simplify down into 100 minus P over 100 times 100, which is just minus P, then times 0.03. Is this part okay? Do I need to elaborate more? I can write it down, not working. Is it clear?
Yeah. Okay.
Clear, then I don't write. Is it okay?
Yeah.
Can I? Okay, good. Then you get to this guy. Then after that, you just have to expand the bracket 0.03 times in. So you get what? Okay, you just get 3 minus away 0.03p. Then after that, 3 is on its own. 0.05p minus 0.03p. It will just be plus 0.02p. Ding. Now the difficult part over here, I believe, is here. Interpreting it as a conditional probability. Here they didn't phrase it given that. They didn't mention the given one. So, but you need to interpret yourself. That is 40. Huh? Yeah. So you must understand that that is 40 is the condition. Like because you can see maybe one way that it can help you is you can put a bracket around that is 40 and you read the sentence again. The probability that a randomly chosen component was supplied by A. Does that sentence make sense without the bracketed part? Is it grammatical? The probability that a randomly chosen component was supplied by A. It flows well, right?
Yeah.
So this that is an additional information given. Can you recognize that? It's like English comprehension already.
Yeah.
Can you comprehend that this is an extra condition? That's why this is a condition. That's why you need conditional probability. Is that clear?
Yeah. Okay.
Then from there, once you know it's a condition, you can just use conditional probability. I'm sure you know how to continue. Right? It's just the first step. That's difficult. Okay, good. So now fp equal to this guy, prove by differentiation that f is an increasing function for 0 less than equal to p less than equal to 100. And explain what this statement means in the context of the question. Oh, so okay, I get it now. So basically they want you to show that the f prime of p first derivative is more than 0 for the domain 0 less than equal to p less than equal to 100. Okay, this is what you need to show. Want to show. You want to show. So let's take a look now. If you differentiate this, I'll go straight to the solution already. So differentiate this, what do you have to use? You have to use quotient rule because it's a quotient. Alternatively, you can do long division first and then you try to simplify, but that's a bit long-winded. I prefer quotient rule. So bottom square first, then bottom d top minus top d bottom. Do you know what I mean? Bottom times the derivative of the top numerator.
Yeah. Okay.
Then minus away top multiplied by derivative of the denominator.
Yeah.
Okay, simplifying, you get to 0.15. Okay, maybe I expand this. 0.05 times 3 is 0.15 plus this one 0.05 times 0.02. Wow, what is that? It's 0.001p. Then you subtract away 0.02 times 0.05 again, so it's minus 0.001p. What a coincidence, they cancel off. Then you're left with 0.15. At the bottom is something bracket square. So here they tell you this is always more than 0 when 0 less than equal to p less than equal to 100. Do you agree? You can just use a GC to draw a graph.
So I can use the GC because I found my answer.
Don't even need a GC. Just say since this is more than 0, I think it can be accepted. Then you just restrict it to x equal to 0 to x equal to 100. In this case, I'm replacing p with x. Then you just look at a graph. You will know that for sure it will be more than 0. Okay? Can. So since this denominator is always positive, numerator also obviously positive. That means positive divided by positive is more than 0. Positive. Can?
Can.
So that means the first derivative, this is f prime of p. The prime, I hope you can see that prime there. Apostrophe. It's the derivative is now more than 0, which means that it's an increasing function. Okay, f is increasing function. So what it really means is that as p increase, the f will also increase. F is what? F is probability that a randomly chosen component that is 40 was supplied by A. So all you need to do is to rephrase it as p increases, meaning what is p? What is p?
Oh.
What is p? Just read the sentence.
The supplier A.
Percentage that company A buys from supplier A, right? Just the company. Company buys from supplier A. So what does it mean? If f of p increases, it's an increasing function of p. Means the graph will look something like this, right? Keep on increasing. Y equal f of p. What does that mean? As you increase the value of p, what happens to your f of p? It will also increase. Does it make sense?
Yeah.
But what does it mean in a real world context? Just translate, use English words to describe this. As p increase, what does p increase means? If this p value goes from, let's say, 10 to 20 to 50 to 80, means 10% of its electronic components come from supplier A. 20%, 50%, 80%. In other words, as you buy more and more components from supplier A, what happens to your f of p? Your f of p increases. What is f of p again? What is f of p again?
F of p.
Is my
The
screen?
0.05 p over 0.02 p plus.
But what does it mean in a real world context? We're answering the question already, but in the context of the question. Need to have an English interpretation, English words. What is f of p? Don't give me the math anymore. Read the sentence. Read the question. Oh, you don't know? Wait. Are you reading this sentence? Is my screen sharing properly?
Yeah.
So what is f of p? What is f of p? It's an expression for the
probability that a randomly chosen component that is 40 was supplied by A.
Yeah, that's all.
But
So
that,
now you, huh?
but that's in the question.
So it doesn't matter. It's
That's the
okay.
answer.
No. That is just F of P. Now phrase it as a sentence. As the math, when we say it's an increasing function, means that as P increases, the function which is increasing increases. Then you just need to substitute P with the real world interpretation. As P increases means what? The company buys more product from supplier A. Then FP increases means what? Means they will provide more and more 40
Pieces.
components. Yeah.
Oh,
Or don't just say more and more 40 pieces. That's very informal. Just quote the question. Math is not so much like English comprehension where you must rephrase the sentence. So no, it's more like a very weak Chinese student who is studying Chinese and doing the 理解问答, the Chinese comprehension, and you just copy and paste the sentence from the question. You know the technique.
yeah.
Just copy and paste only, and then you rephrase a little bit. So let's look at the sentence. Let's look at what they provided in the solution. It's really just copying and pasting the question. When a company buys a larger percentage, some fancy English, you can use any other similar phrasing of electronic components from supplier A. The probability that a 40 component that is from supplier A increases. That's F of P. You see, the probability 40 component is from supplier A. That's just the event provided by the event that the probability F of P is referring to. Increases. I'll just the keyword is this two part. Larger increases. That's the interpretation of an increasing function. Okay, that's all.
Oh, okay.
Yeah, nothing much. Okay. 10, let's move on. So question 11, what happened? Question mark, you draw a circle, but then you put a tick. So do I go through?
I don't know if like the I can use the choose the NCR.
Huh?
Like I don't know
Oh.
if my method is correct because the answer key, like I think I'm not sure. I think the answer key use another method.
Okay, let me read the question first. Okay, they times 4 factorial. But for you times 2 factorial times 2 factorial. Okay, let's see. Class of 20 pupils consists of 12 girls and 8 boys. For a discussion session, 4 officers are chosen to be at random as chairman, recorder, proposer, opposer. Fine, giving your answer correct to 3 SF. Probability that all 4 officers are girls. So we start off by 12, choose 4 girls and arrange them as 4 factorial. Divide by 20, choose 4 times 4 factorial. Now, why would you need to times 4 factorial when you're trying to get a committee? The order doesn't really matter.
But I thought they have like 4 like specific rules.
Oh, right. Because they have 4 specific roles. That's why the order will matter. Okay. Correct. Chairman, recorder, proposer, and opposer. Because they are distinct from each other, they don't just get to be selected in the committee. You still need to arrange them once they are selected in the committee into their respective roles. Correct. Okay. That's why you have to times 4 factorial, top and bottom as well. How about part 2? Probability that 2 officers are girls and 2 are boys. Okay, so actually it's the same. You see, look at their solution. They did the same thing as you. Times 2 factorial times 2 factorial. Choose 2 girls to be proposer and opposer. Or whatever 2 roles, it doesn't really matter. Then among remaining 18, choose 2 of them to be chairperson and recorder. Then who is the proposer and opposer? 2 ways. Who's the chairperson and recorder? 2 ways. 2 factorial. You can always rearrange it because it's multiplication. Yeah, your method is fine.
It's like the first method better.
It's simpler lor. You just have to choose 2 people and choose another 2 people, and then you just arrange them once they are in the team. Think of it as selection and then arrangement. The first part is you are selecting the people into the committee, like student council or something like that. And then now 4 factorial is the number of ways to arrange. It's a systematic way that follows the same format every time, so you can replicate during exam. Select, arrange. Arrange always got a factorial. Select always involves a choose. This is the committee kind of question. Right? Very standard. I think it makes sense. But of course, you can break it down into the 2 girls. You can arrange those 2 girls. They have how many 2 factorial ways to arrange them, and 2 boys also can arrange. Same answer. Okay, Ken, then let's take a look at your other one. What is this? Circle. This is part 3. How come got 2 part 2s? What?
I think it's part 3.
Okay. Oh, you're labeling very funny. Part 3. Probability. Sorry. Probability that the proposer and opposer are both girls. Okay. Oh, wait a minute. Hold on a second. Let me see. Sorry. This is for part 3. This was for part 3. Sorry, I was reading wrongly. This is the only answer they provided. Yeah, I think it's simpler to think of it this way, just times 4 factorial. Okay, can we clarify that? Let's just move on to part 3. For part 3, probability that the proposer and opposer are both girls. How do you do that? Oh, this one is using the drawing without replacement idea. Have you seen these kind of questions? Like, what's the probability of, let's say you have a ball, let's say you have a box with a bunch of balls, a black one, a blue one, and then maybe a pink one. What's the probability of, okay, let's say there are 2 blacks and there are 3 blues and 2 pinks. So what's the probability? So what's the total number of balls first? Let's just calculate that. 1, 2, 3, 4, 5, 6, 7. Then the question is, what is your probability of drawing 2 blue color balls? That will be 3 out of 7, then times
2 over 6.
Because you already draw one without replacement, so minus 1. Drawn without replacement, I should mention that. Means you take out from the box, you don't put the ball back in. Drawn without replacement. Okay, so same idea here. You are also drawing, this time it's not balls, but rather people. You have 12 girls, you want to draw 12 of them to be inside the team. So 12 out of 20. That's your first girl to be your recorder or proposer. We'll think about that later. Then after that, we will have only 11 girls left among 19. So that's your second girl that will be chosen to be inside the team. Proposer and opposer, both girls. So that means 2 girls selected already. Now we have to choose the others. Let me think. Do you need to care about the others actually? 18 over 18 and 17 over 17. That's a bit funny. Right. Okay. Correct. Actually, this is, where did they get this first 18 from? It's because you have a total of 20 students, pupils. That's made up of those 2 chosen girls plus 18 other people. 18 others. That's why you have 18. Then you have to randomly choose one of these. You only have 18 choices out of all 18. So that's just 18 over 18 for the 3rd position. And then the 4th position, you just count down after you've chosen one guy. So you have 17 possible people to choose from among 17. So it's just 17 over 17. Because there's no more restrictions on the 3rd and 4th guy. So all 18 out of 18 candidates can be chosen. All 17 out of 17 candidates can be chosen fairly. That's why you multiply them like that. Okay, another way to think about it is you count the number of ways that you can form a team with those two girls. That will be 12 choose 2. Then you divide by the total number of ways that you can choose two people to be inside your proposer and opposer. The number of ways to choose two people to take on the role of proposer and opposer. It's just 20 choose 2 as the denominator. Okay, that's 2 ways. Then they provided 2 other ways, method 3 and method 4. Okay, let's go. So still 12 girls, 8 boys. 2 of them we want to select. 2 plus 10 gives you 12. 2 of them has to be selected as the proposer and opposer. Thesis and antithesis. Doing some debate team. Okay, so how do we do that? First numerator, you want to count the total number of ways that you can select those 2 girls. So among 12 girls, you want to choose 2 of them to be proposer, opposer. Then once you have chosen those 10 people, how many remaining people left? 18 people. That's why we have 18 choose 2. Choose the 2 for the other 2 roles. Okay. Among the remaining 18 people, you want to choose 2 of them to be the other 2 roles, chairperson, recorder. Then you can arrange them. The 2 girls, you can arrange 2 factorial ways. The 2 other people can arrange in 2 factorial ways to take on the role of proposer, opposer, or chairperson, recorder. Okay? Can numerator okay so far?
Yeah.
Then you divide by the total number of ways, which is there are 20 girls, you want to choose 4 of them. Sorry. There are 20 pupils, you want to choose 4 of them to be inside the team. But there are 4 distinct roles, so you can times 4 factorial ways to assign the roles to those chosen 4 people. Then that's how you get your probability. Also, okay. Then method 4, super long-winded. They go and calculate all the possible cases. 2 girls, 2 boys, 3 girls, 1 boy, 4 girls inside the team. Where you lock in those 2 girls to be the whoever, those special 2 girls. Can I leave this to you to work it out? Or should I go through? We go through? Okay, I'll just go through.
Okay.
Can okay, can. So what we are doing is we are considering 12 girls, 8 boys again, but this time we want 2 girls. We still want 2 girls to be proposer and opposer, but then we want to consider separate cases. Case 1, we are considering those 4 roles, right? Girl number 1, girl number 2. Then there's still 2 remaining positions. What should we do with the remaining positions? We have to fill in the blank. So here they are considering what if we just put in 2 boys. That's case 1. Then for case 2, still the same situation with 2 girls. Still the same situation with 2 girls, but then now we have 2 blanks again. How should we fill in the blank? I'll just copy and paste this for my case 3. Maybe they can fill in this time with, instead of 2 boys, it will become 1 girl and 1 boy. Then now finally the last case, what do you think is the last case? Got BB, GB, then what's the last one?
Like 4 girls.
4 girls or GG. Yeah. So now take note that the G and B, the order is not specified. Even though I wrote down G on the left and B on the right, it could always be B on the left, G on the right. So we need to consider all those cases. So now that we have established the cases, we can proceed to count each one, the probability of each case one by one. So first case, 2 girls, 2 boys. So how do you choose 2 girls to be proposer and opposer? Remember that there are, let me just bring this down. Let me just bring this down. Remember that there are 12 girls in total. So we want to choose 2 of them to be the proposer, opposer. So 12 choose 2. Likewise, there are also 8 boys. We want 2 of them. So we choose 2 of them to be the other 2 roles. But since they are distinct roles, that's why you have to times 2 factorial times 2 factorial to assign the roles. This part is the selection into the committee. This part is the arrangement. Okay, it's not really arrangement. In this case, it's assignment. Assigning with a row. Particular row. You can just think of it as the same as arrangement. Okay, then you divide by the total number of ways. This denominator we already discussed in method 3. Or 20 choose 4 times 4 factorial. Okay? Can?
Can.
Okay, that's case 1. Now move on to case 2. Now we have 2 girls and 1 girl, 1 boy. So that just means we have 3 girls, 1 boy. So how do you choose 3 girls from 12? Just 12 choose 3. You still need 1 boy. But then let me think a little bit. What's going on here? Think of it as okay. I looked at 12 choose 3 already. Now let's focus on 8 choose 1. We have 3 girls already. Now we still need that 1 boy. So we should look at the remaining 8 boys, right? And then we choose one guy to be inside the team. So 8 choose 1. Okay, then now we have to assign roles. So assign roles, right? Let's say we have the 3 girls. We have 2 of them. They are the chosen ones who will become proposer and opposer. So that's why we need a 3 choose 2. Okay, then one girl will be just doing some other job, not proposer, not opposer. So 3 choose 2. That's for the assigning of the roles. Then for this 2 factorial, it's assigning who among these 2 girls are. Let's say you selected the 2 girls already that will be proposer, opposer. You still need to arrange them. Who is the proposer? Who is the opposer? That's why you have another 2 factorial. And then finally, now we look at the boy. No, not the boy. We look at the 2 remaining people, not the proposer, not the opposer. So these 2 are out. We have the last girl and the last boy. We have to arrange them so that one guy is chairperson, one guy is recorder. So they have to fight. Who gets the role? Then they have 2 ways to do that. 2 factorial. Is this okay? Mic test.
Yeah.
Can all? And then you still divide by the denominator. Sorry?
Yeah, can.
Can hear? Okay, good. Then finally, the last case, we have all 4 are girls. So again, 12 girls, you want to choose 4 of them, then just arrange in 4 factorial ways. Divide by the same denominator. Then sum the 3 cases, you get 33 over 95. So basically, this guy, you calculate a number, another number, add them together. At the end of the day, it will just become 33 over 95. Can? Yeah, super long-winded. So hopefully you are able to see the most optimal way, which is the countdown method. Or the most efficient way. Wow, this one's super short. Just count the number of ways to choose the girls. Then the boys will automatically follow. So just 12 choose 2 to get the girls. And then you divide by the total number of ways. That is your probability already. Is that okay?
Yeah, can.
Okay, good. Question 11 done. Next. Oh no, I haven't had time to go through new topic. Okay, question 12. Let's take a look. Nope. Let's just go through the entirely. Okay, let's see. Oh, there's a part 4 as well. Sorry, I forgot to go through a part 4. Still on question 11. Sorry, let me go back. Part 4, the probability that the proposer and opposer are of opposite sex, given that the chairman and recorder are both girls. So girl, proposer, opposer are of opposite sex. So can be girl, boy, or boy, girl. That means there probably will be 2 cases. Girl, boy, or girl, boy, girl. Let's just look at the solution. Okay, let me copy down the question as well. Okay, let's take a look. So, what are all these numbers? What does it mean? Okay, let's figure out. 12 over 20. Remember, there are 12 girls and 8 boys. So what do? We can consider. Let me read first. 12, 8. Correct. Yes. So we already considered two cases, right? So let's just write them down first. Chairman, recorder, proposer, opposer. These are the four roles. Then what are the two possibilities that we can have for their gender? Chairman, recorder, they have no choice. They force it to be both girls. But proposer, opposer, opposite sex. So we already established that it can be two ways. It's either girl, boy, or boy, girl. Right? So these are the only two possibilities. Can you see that? Can you see that there are only two possibilities? Mic test.
Yeah.
Yes. Okay, good. Then in that case, we just need to count the probability for each case. So here you see a plus sign. It's actually probability of one case and probability of a second case. Add them together. Okay. So we're gonna count the number of ways for the first possibility. If you want the first position, maybe I should have swapped this around to follow the solution like this. Proposer, opposer, chairman, and recorder. So how do you get a girl as a proposer first? There are 12 girls in total over 20, so 12 over 20. Then now you need a boy for the opposer. So what would it be? There are 8 boys remaining divided by 19 remaining people. 19 remaining people. So 8 over 19. Okay. Then for the other remaining 2 girls and girls, we must count. We already chose 1 girl and 1 boy. So how many girls left? How many girls left? Sorry, Don, I can't hear your audio.
Oh, sorry, I think there was. Oops.
Mic test, can you hear me?
Hello.
Yes, I can hear you. Good.
Yeah, sorry. I think.
Yeah, so we already established, right? 1 girl, 1 boy for the proposer, opposer. So 12 over 20 times 8 over 19. Then how about this one? Where did the 11 come from?
The girls.
The girls, right? You already chose 1 girl for the proposer. That means that how many girls left? 11 or 12 minus 1. That's why, and also the denominator, you'll notice you'll just keep on counting down because we have fewer and fewer people total. So 11 girls out of 18 can be chosen as your chairman. Then how about the last one, the recorder? Still a girl, so that means you count down. Instead of 11 girls, it becomes 10 girls because one of them has been chosen as chairman. Then 10 out of count down, so 17. Okay? That's the first case. Then the second case, same thing. Boy, girl, then girl, girl. So how do you choose a boy first as a proposal? You just need to take 8 boys out of the 20. Then you multiply by the next case, which is you want a girl among the remaining 19 people. There are still 12 girls, so it's 12 over 19. Then after that, now you have the remaining 2 girls to be chosen as the chairman and recorder. Since we have already chosen one of the girls from here to be the opposer, that means we're only left with 12 minus 1, 11 girls out of countdown again for the denominator. Total number of people will just reduce by 1 each time. So there's only 18 people to choose from, and you need 11 people. You want 11 of those girls, the remaining girls. Next, you have the last and final girl. So again, you count down the number of girls. You have already chosen 2 girls. One is a opposer, one is a chairman. So you're only left with 12 minus 2, 10 more girls out of the 17 remaining people. So times 10 over 17. So that's your probability of the second case, probability of the first case. But then you still need to divide it by the total probability of in general. So you just take the 12 girls over 20 multiplied by 11 girls out of the 19 so that you can obtain your 2 girls as your chairman and recorder. and you'll get your final answer. Okay, then the other way to do it using the choose method is you have, what is it? Wait, let me think. Two of the girls, you think of it like this, two of the girls are locked in already. Oh. Chairman and recorder. So that means we only left with 12 minus 2, 10 people, 10 girls to choose from. We want one of them to be our president, proposer, and one of them to one boy to be opposer, or just the other way around, boy then girl. So that means that we have to choose one girl followed by one boy, which is 10 choose one, 10 remaining girls, we want to choose one of them to be either the proposer or opposer. And then you have 8 boys, you want to choose one of them to take on the other role. 8 choose one. Once you, this girl and girl, you don't have to care anymore because it's already locked in. Then you just have to divide by the total number of ways, which is 18 people. Is it 18? Yes, it's 18 because total here at first is 20, but you already locked in 2 people. So you're only left with 18. 18, then you choose 2 people among these 2. Then that will be your probability. Okay? Can?
Okay, can.
This last way, I'm going to skip it. You can go read on your own. Let me know if you want to know more.
Okay.
I think this is good enough. Okay, next one. Question 12. A man writes 5 letters, one each to A, B, C, D, and E. Each letter is placed in a separate envelope and sealed. Okay. One each to these are people, A, B, C, D, or destinations. And each letter is placed in a separate envelope and sealed. He then addresses the envelopes at random, one each to A, B, C, D, and E. Find the probability that the letter to A is in the correct envelope and the letter to B is in an incorrect envelope. Okay, so we just draw a tree diagram now. I guess that's a simplest way to do it. A represents event where letter to A is in correct envelope. B represents event where letter B is in the correct envelope. So now there are 2 cases, A or A prime. A means you are the correct letter go to the correct person. A go to A. Letter A goes to person A. A prime means there are 2 cases. Wait, A prime, what does it mean? The event where the letter to A is in the wrong envelope. So there's a letter towards A, but you put in the wrong envelope accidentally. The probability will just be 1/5 and 4/5 because you're just writing it randomly. One particular letter among 5. So 1/5 here. Then the other case is complement, so 1 minus 1/5, you get 4/5. Now, since you already have locked in one of the A's, the letter A goes into envelope A in the exactly already. That means that we only have 4 more letters and 4 more envelopes. Then what's the probability of picking up the letter B and then slotting it into the correct envelope? You only got 4 envelopes left, so it's 1 out of 4. That's why there's a 1/4 here. Does it make sense? No, it doesn't make sense.
Yeah, it makes sense. I did it like with replacement, I think. Okay.
Oh.
Yeah, okay.
Wait, okay. Can. So 5 letters. I'm just gonna draw it in. Then you can interpret lah, huh? So that's 1/4. That's why the complement here will be 3/4. So over here they tell us PA equal to PB equals to 1/5. Yes, that's okay. That's true because it's the first time that you're selecting one of the letters to go into the envelope. So there's 5 envelopes here. That's why you only have a 1/5 chance. Now for part 1, find the probability that the letter to A is in the correct envelope and the letter to B is in an incorrect envelope. Incorrect envelope just means B prime. So you want both to happen. There's an N, right? Every time you see N, you associate it with intersect. Okay? Intersect. Then A intersect B prime. So what would that be? You need to understand that it's really just referring to this branch. So 1/5 times 3/4. Here they went, they were a bit extra lah. They just use the proper notation, right? It's the second branch onwards. This 3/4 is just a conditional probability. B prime given A. but honestly, not needed for this question. You just need to read the tree diagram. Go along this branch, you see a number, you multiply, and that's your answer.
But the events are not independent.
No, no, I don't know. It doesn't matter.
Then how
Tree
come
diagram.
can use the tree diagram? Like, is it not separately?
No, I already explained just now, right, about the conditional probability. From second branch onwards, it's always a conditional probability.
Yeah,
So,
but like, how I know it should be in a branch?
From practicing questions. Here, because there are two separate events, but you are selecting a letter A, then a letter B. So it makes sense that you have a branch. Draw a tree diagram. Consecutive events, sequential events.
Okay.
Right? They start talking about letter to A and then letter to B. That's two separate events. So you should have branching. At least two levels.
Okay.
Actually, the roll die question, just now when we were doing at the beginning, event ABC can also be drawn as a tree diagram. It's just very long-winded. 6 branches. And then within each branch, you branch out into 6 more. You can do that as well. But sometimes using a bit of logic, you realize it's a bit too long-winded. Then you must change your formatting. It's like writing notes. You don't just memorize one specific method, right? You just must adapt accordingly. In this case, it's a bit too long-winded to draw 6 and 6, 36 branches. So we draw a table instead of 6 ways and 6 ways. Then we draw 36. I know it's still quite long-winded, but I think it's a little bit better. Okay?
Okay.
Draw a table format instead. So tree diagram, table format, up to you lah. But in this case, there are only 2 cases, so 2 branches, and it's sequential events. That's how I know you'll need to draw a tree diagram. Letter towards A, then letter towards B. Actually, almost all the questions can be, as long as it's a sequence of events, you can draw tree diagram already. Okay?
Okay.
Yeah. So you just multiply and then you get the answer for part 1. Moving on, part 2. Find the probability that the letter to A is in the correct envelope. So it's this branch here, this event here. Given that the letter to B is in an incorrect envelope. Oh, so that means it's actually incorrect envelope. It means it's B prime. B prime. So it's a condition, right? They already mentioned given that this guy. So this is B prime. Letter to A is in the correct envelope. That's your A. That's your A. So that means you just want to find out P of A given B prime over here. Oh yeah, by the way, actually this style of question is quite common. You just consider 2 events are A and B. Then after that, you draw a tree diagram. Then after that, they will always have a conditional probability here. You start to see that there's incorrect envelope, then correct envelope. There's like 2 possible cases already. Then that will also help to hint to you that you need to draw a tree diagram. True and false. True and false.
Oh.
Yeah, maybe that can help you. I'm not sure. Also, the given here tells you that it's a conditional probability. So you need to phrase it as a conditional probability, which means that you need the event A or A prime, B or B prime. So it will be smart if you define your events at the beginning. Define it carefully. You may need to go back and forth. Sometimes your event, you define, you realize, oh, maybe I should be a bit more precise in my event. I cannot just say event of choosing letter A. No. Choosing letter A, that's just, that's a given. It should be choosing the correct envelope. That's the answer. That is your correct way to define your A. Yeah, need to go back and forth on sometimes. So anyways, now part 2, P of A given B prime, you just use formula. Once it's at this stage, it should be quite easy. Just A intersect B prime over P of B prime. You know this formula. Then you just have to fill in the blanks using the tree diagram. A intersect B prime, we have already found that out from part 1, 3/20. But P of B prime, what's that? It's just this branch over here. Oh, yeah. So, okay. Then you just take 1/5 times 3/4 and you obtain your 4/5, right? Is that right? Actually, sorry, no, it's not a branch. If you took this branch here, it would be P of A If you took 1/4 times 3/4, it will be P of A intersect with B prime. Oh, this branch here, 1/5 times 3/4 get P of A intersect B prime. That's wrong. We don't want that. We just want P of B prime. So we need to know that P of B of selecting the correct letter, taking the letter B and then selecting the correct envelope B and slotting it in, that probability is 1/5. So B prime will just be 1 minus 1/5, which is 4/5.
Oh.
Does it make sense? Do you get what's going on with the situation? Maybe I didn't explain so well.
Yeah. So yeah, it's just 1 minus 1/5.
Yes, correct.
Okay.
Yeah. There are 5 random letters, then you don't know. Maybe those letters, there's a correct A, B, C, D, and E letter, but then they are jumbled up and they are hidden. Just play a little game where the A is the names of the letters are hidden. So you don't know which is the correct letter. Then here is letter B. You're trying to figure out where can it go. Here, 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 or there. 5 possible ways. You're choosing at random, so it's 1/5 probability. You randomly choose one of the letters, so you slot your letter B inside. There's only a 1/5 chance that you can get it right. Here, or here, or here, or here, or here. 1/5 chance. Then B prime means that you have chosen the wrong letter. 4 out of 5 times you will get it wrong. So 4/5. Okay, Ken, then just divide by 4/5 and you get the answer 3/16. That's your answer for part 2. Moving on, part 3. Find the probability that both of the letters to A and B are in incorrect envelope. Both are incorrect. So what does it mean in terms of the notation? It will just be A prime intersect B prime, right?
Yeah.
Incorrect means must have prime. N here tells you must have intersect. So now we have converted a very complicated English statement into just probability of A prime intersect B prime. Much easier. You know how to handle this, right? What is it equal to?
Dot A union B.
Yeah, okay, good. You remember. Okay. So maybe it's worth memorizing. Alternatively, you can just draw out a Venn diagram. Shade in your A prime intersect B prime. Of course, you don't actually shade it in like that. Don't waste time during exam. Then you just realize it's just shaded minus total area minus way unshaded, which is 1 minus P of A union B. Okay, good. So now you just have to, they already draw a diagram for you nicely. So 1 minus P of A union B is just PA plus PB minus P of A intersect B. Then you just figure out the probability of A, probability of B, and probability of A intersect B. A intersect B here is really just this branch. This guy is P of A. That guy is P of A prime. This guy is P of B given A. This guy is probability of B prime given A. Then over here, if you multiply 1/5 times 1/4, it's P of A times P of B given A, which is exactly P of A intersect B. Okay, just substitute in the formula and you can prove for yourself. This is just P of B intersect A over P of A. P of A will cancel off, you're left with P of B intersect A. B intersect A, you can swap around, so it's A intersect B. I don't show you the proof, is it okay?
Yeah.
Can Yeah, so that's how you get this P of A intersect B, 1/5 times 1/4. I do not know whether they are independent events or not. I just know that from my tree diagram, I know that this 1/4 here is a conditional probability, right? Just counting down without replacement, right? We have already chosen one of the letters. So from 5 choices, right? From 5 choices, you pick one of them, 1/5 chance. You already chosen one of those letters. So how many letters left? 4 letters left. That's why the probability of picking the correct one will become 1/4. So this is conditional probability. It's conditioned on you select A at the beginning. You selected the correct envelope A to slot in letter A in at the beginning. Okay, so no, I do not know they are independent events or not. They could be, they could not be, I do not know. But I just know that this is conditional probability, this is probability, I'm multiplying and using the formula, I'm able to obtain A intersect B, which is exactly what is required. 1/5 times 1/4 will give you P of A intersect B. I am not using P of A times P of B here. Okay?
Okay.
Yeah.
Okay.
This part is not P of A times P of B. In fact, P of A times P of B, you know that it's just 1/5 times 1/5, right?
Yeah.
Over here. So definitely not equal. So from here, we can tell that A and B are also not independent events. Actually, yeah, we can tell that straight away. They are not independent events. Because the probability of drawing A. Sorry, no. Sorry, I take that back. I cannot tell immediately. I had to do this calculation. Yeah, so from here, there was we can already prove that we can already prove that event A and B are not independent events. Is that okay?
Yeah.
Bonus not related on A, B are not independent events because P of A times P of B equals to 1/5 times 1/5, which is 1/25. And P of A intersect B is 1/5 times 1/4, which is 1/20. They are not equal. Not equal, therefore they are not independent. Equal then independent. Okay?
Okay.
All right, so calculate this and you eventually get 13/20. The calculation, I'm sure you know how to type in a calculator. I'm not going to go through. Moving on. Ken?
Okay.
I move on. Good. Next. Question 13 is fine. Good. Part 4, not fine. Oh no. Let's take a look at question 13, part 4. Question 13, part 4, let's see. Our bag contains, wow, got a star, so scary. Bag contains 4 red counters and 6 green counters. 4 counters are drawn at random from the bag without replacement. Calculate the probability that this is the one you want to ask. Let me read the question first. Maybe we have to use part 1 to part 3 to answer part 4. Calculate the probability that all the counters drawn are green. Okay, so it's just 6 out of 10, then 5 out of 9, and count down, so on and so forth. Part 2, at least one counter of each color is drawn. So we just take a complement. So 1 minus P of all counters are red or green. And okay, then part 3 is at least 2 green counters are drawn. So at least 2 means complement will be 0 or 1. Then you just 1 minus the probability of those cases, where it's 0, where it's 1. 0 means all is red. Then part 4, at least 2 green counters are drawn. Given that at least one counter of each color is drawn. Okay, that seems very familiar. You see, given that at least one counter of each color is drawn. Where did I read this phrase before? Which part? 1, 2, 3.
Part 3.
At least one counter of each color is drawn. Part?
Part 2.
Part 2. Okay, I color code for you. Okay, then after that, I think you are reading this part. 2 green counters, at least 2 green counters are drawn. That's part 3. Okay.
Yeah.
So let's just call this event, I don't know, B. Call this event A. So part 4 is really so part 2 is just finding P of B. Part 3 we already found P of A. Then over in part 4, what we are actually interested in is P of what is it? What given what?
At least 2 green counters are drawn.
In terms of the event A and B, purple color is event B.
Oh, it's A.
Green color is event A.
Event B.
Very good. Yes, correct. So of course we have a formula for that. It's P of A intersect B over P of B, right?
Yeah.
I assume you know this. Then P of A intersect B, that one we may need to think a little bit, but P of B, we already know the answer. It's just the answer from part 2. Then the numerator, we need to calculate it. A intersect B. What's that? At least one counter of each color is drawn. At least 2 green counters are drawn. I think that's the main difficulty with this question. This part okay, right? Up to this step.
Yeah.
So the only difficulty now should be calculating the P of A intersect B. This is a common question. part 4. You just have to make use of the answer from part 2 and part 3. Or let's just figure out, let's just read the solution now. So that's what they did here. Let me see. What did they do? They did something a little funny. They did it at the numerator here. Probability of 2 green, 2 red plus 3 green, 1 red. Those are the two cases. This is the A in the set B. The bottom one is P of B. The required probability is P of A given B. Okay, they didn't use notation, but I like to use notation because it's easy to remember the formula. P of A given B become P of A intersect B divided by P of B. Sorry, my intersect looks very bad. Let me redraw it nicely. Okay, good. So P of A intersect B, let's read again what's A and what's B. A is the event where at least 2 green counters are drawn. At least 2 green. B is the event where at least 1 counter of each color. 1 of each. Okay, then that just means you must have at least 2 green. Then the other color is red, so 2 red, total of 4. Or you can increase it to 3 green, then 1 red. Can you have 4 green and 0 red? 4 plus 0 is 4. Can we have that?
No.
Why cannot?
Because they say at least 1 of each color.
Very good. Yes, because 1 of each color requires the red and green as well. Here, 0 red is not allowed. Good, good. Okay, you understand that. So those are the only 2 cases. Then you just go and calculate. So that's what they did here. So how? 2 green. I forgot the number already. 4 red and 6 green. Okay. Is it without replacement? Yes, drawn without replacement. So just count down only. Let's calculate that. So 2 green, that means you have 6 out of 10 for the first green, 5 out of 9 for the second green. Then after that, 2 red. You have 4 reds out of the remaining 8. Then count down again, -1, -1. So 3 out of 7 for the second red. Okay, but then here, why did you have to arrange that? Oh, let's see. Okay, over here, the order actually matters. The order actually matters because the order that you draw out those counters from the back matters. Each time you draw out, it will affect the probability of the next guy that you draw out. So that means the sequence in which you draw red and green will matter. So you have to consider all the possible ways that you can arrange them, right? That's why you have to times 4 factorial for all the 4 different counters. And then you have 2 repetitions. So 2 of them are the same type, so you divide by 2 factorial. Another 2 of them are of the other type, so divide by 2 factorial. This part, okay? Okay, then for 3 green and 1 red, you just do the same thing. So 6 green out of 10, 5 green out of 9 remaining, 4 greens out of 8 remaining. Then after that, you go for the reds. There are 4 reds still out of the 7 remaining. And yeah, that's all. 3 green, 1 red chosen already. But wait, the order matters. So we have to times 4 factorial. 4 counters, so you need to arrange in 4 factorial ways. However, there's a repetition of 3 of them. So we don't want to the green counters are not distinct from each other. So we are considering them as duplicates. 3 duplicates, then we have to divide by 3 factorial. Okay, then add them together, you get 17/21. Final answer will just be, this part is just calculating the numerator. So it's 17/21 divided by 97/105. Where did this 97/105 come from?
The previous part 2.
Exactly. No, because it's the same event. Must read the English words. If you want, you can do something like a highlighter, but really, I'm not sure if you can use highlighter during A levels. Just underline lah.
Yeah.
So you can remind yourself, and you can even declare if you want. Let event A be the event where you draw at least 2 green counters. Let event B be the event where you draw at least one of each type, each color of counters. Okay, good. So now answer the last part. State with a reason whether or not the events at least 2 green counters are drawn, which is the event A, and at least 1 counter of each color is drawn, which is the purple, are independent. How? How do you prove independent again? What's the three conditions? Can you recall? How do you prove event A and B are independent? What are the three? Cannot remember?
The P intersect is P, like the P A intersect B is PA times PB.
Good. Next one.
There are three.
Yeah. A given. Remember, you want independence. I don't want to be dependent on the guy. But if I tell you you are dependent on B, given that B is true, what does A have to do to break free? So this will be equal to?
PA given B.
Ignore the B. You must ignore the B. You want to be independent even.
So it's just PA.
Just PA. Be independent on your own. Don't need to depend on B anymore. The other way is just swap it around. So P of B given A equals?
PB.
B must break free from the given condition A. Your given condition A. And then you just left with P of B. Okay, good. Yeah, so these are the three formulas you need to know. At least one of them must be proven to show independence. We already have P of B here and P of A here already from part 2 and part 3. And P of A intersect B, remember? We calculated that just now? Count down times 4 factorial over 2 factorial, 2 factorial, remember? Over at here. 17 over 21.
Yeah.
Then that means which formula should we use? The first one, we have P of A intersect B. We have P of A, we have P of B. Just sub in the formula and verify does it follow this first formula or not. So let's do that. Can I remember? Part 2's answer is P of B, part 3's answer is P of A. So you just times part 2 times part 3. Then you check that is it the same as the P of A intersect B. Clear?
Yeah.
Okay, good. So part P of what is it? This is P of A intersect B. I should label this P of A intersect B. Let's see. P of A. Oh, they did given B. Okay, never mind. I prefer my style. P of A intersect B. We already calculated it to be 17 over 21. Then P of A times P of B. Let's calculate that. What's P of A again? The event from part 3, which is 37 over 42. Multiply by P of B, which is B is purple color, part 2. Answer from part 2, 97 over 105. We can just type in a calculator. I don't know how to do mental sums so quickly. I need a calculator. Okay, and I end up with 3589 over 4410. So of course they are not equal, therefore, okay, I should write this down. This implies that P of A intersect B is not equal to P of A times P of B. And therefore, A, B are not independent. Okay?
Yeah.
That's one way to do it. Oh, they actually calculated P of A given B, which is, the answer over here. Yeah, it's not equal to P of A. Yes, correct. That also works. 85 over 97 is not 37 over 42. Can, also can. All right. By the way, I always write down independent and equal. Just take note that for not independent, to show not independent, you just show it's not equal. I think that's obvious. Oh, not equal, but I never write down, so I only mention it verbally. I better write it down somewhere in case you forget. Here, to show independence, you show equality. Then the other case, if you show not independent, you show not equal. Yeah, which is what I'm doing here, not equal. Okay, good. Moving on. Let's see. Method 2. I'm just gonna skip it. Did I go through this 13 part 4? Yes, I did. Okay. Just make sure you identify that you're going to make use of your answer from part 2 and part 3. Make use of your answer from part 2 and part 3. Okay. Yeah, 14. Oh no, part 3, part 4. What happened? Let's take a look. Skip. Group of 15 people consists of one pair of sisters, one set of 3 brothers, and 10 other people, plus 10 more. So what's the total number of people? 1, 2, 3, 4, 5, 15 people total. So yeah, these 15 people are arranged randomly in a line. Line not circle. So don't need to divide by n don't need to divide by n. N factorial over n minus 1 bracket factorial. Don't need. Just a line. So find the probability that the sisters are next to each other. So next to each other means what? Which method do you use?
Like the grouping method.
Insertion. Complement method. Complement means you take total minus away the opposite of what you want. Sometimes the opposite is easier to count. So yeah, grouping method, right? Must group the sisters together as one group. So draw a box like this. Then after that, how many groups will there be now?
14.
14 groups plus 14 others. Oh, correct or not? Wait, sorry, no, 13 others. 13 others. Then total of 14 groups. So how many ways to arrange 14 groups? Just 14 factorial. But then the two girls because they're in a row, they are definitely not identical. Sister number 1 and number 2. It's either 1, 2 or 2, 1. So there are 2 factorial ways to arrange them. But then you have to divide by the total number of ways, which is without restriction, which is 15 factorial. Simplify and you get 2 over 15. Can? Okay, good. Oh yeah, by the way, you can simplify this without a calculator. 14 factorial times 2 factorial over 15 factorial. You must understand that 15 factorial is 15 times 14 times 13, count down all the way. So it's just 15 times 14 factorial. Then the 14 factorial can cancel off. You're left with 2 factorial over 15, which is 2 over 15. Don't need calculator. Okay?
Okay.
Yeah, anyways, but you have a calculator, whatever. Part 2. Find the probability that the brothers are not all next to one another. Not next to one another means what? Which method?
The complement method.
Complement method would be easier. Another way is insertion. You draw all the people and then you insert the brothers into the spaces in between them so that they are not all next to each other. Actually, not all next to each other. If you try insertion, it's not recommended because insertion for part 2 is difficult. Because when they mention not all next to one another, here's one way. Let's just say that there are fewer people. I'm just going to draw underline to represent the people. Here is brother. Here is a brother. Here is a brother. Is this arrangement okay? Not all beside each other? Does this satisfy that condition? Is this one such example? I mean, I'm not drawing off with all the other 12 other people, 15 minus 3. I'm just considering this as a simple example. Probability that the brothers are not all next to one another. Is this okay?
Yeah.
Yes, of course, they're all separated, so that's fine. But now let's consider what happens if 2 of them are separated, but the third brother, well, here's what I'm gonna do. I'll put them over here. This brother is side by side. Is this okay?
No.
Wrong. This is acceptable. Not all next to each other means that at least one of them is separated. Here, there is a separation for the third brother. So this is fine. This will also be included.
Oh.
Do you see how difficult it is to count this now?
Yeah.
It's not just all of them have a separation. Here, the phrasing, not all next to one another, is very, very evil. It considers the cases where B and B are side by side as well. And then you need to consider all the different gaps in between them. Wow, too difficult already. So that's why your intuition is fine. Very good. Use complement method. Or were you looking at the solution?
No,
use complement. Yeah, use the complement method is correct because the opposite of not all next to one another means they are always next to one another. So all 3 side by side. That will require what kind of method? Grouping, right? Grouping method. So you start to see these three methods are always linked together. Yeah, just make sure. Oh my goodness, let me move the numbers away. Yeah, just make sure you know all three methods and you will be good to go. This is a extra irritating question where it's really just a counting question with an extra step of dividing by the total 15 factorial, so you can get your final answer. If you forget to divide, then your answer will be wrong. So how this one, all brothers together, this one requires grouping. How many groups will there be now? Brother, how many others? What's the total number of groups?
Plus 12 others, so it's 13.
Correct. So there are 13 groups. That's why you have 13 factorial here. But why times 3 factorial? Because there are 3 different brothers. You can arrange them in 3 factorial, which is 6 different ways. So that's why times 3 factorial. Then divide by the total. Okay. Here, why is it 1 minus? It's because probability always has a total of 1. All right. 1 minus. Can? Yeah, then just sub in the calculator and you'll get your answer 34/35. Moving on, part 3. Find the probability that either the sisters are next to each other, or the brothers are all next to one another, or both. So we must draw a Venn diagram. This is event A. This is event B. Let me just shrink it down a bit. Oh no. Okay, event A is sisters next to one another. Event B is brothers all next to one another. So it could have so if it's a region over here, one such example where it's just purely the event A but not event B, it would mean something like this. Sisters next to one another, then the brother is inserted, then a blank space, then a brother is inserted, and a blank space, and a brother is inserted, and blank space, and blah blah blah. I'm not gonna draw the rest of the people. Okay, this is one such example when the brothers are totally separated and the sisters are side by side. Is this okay?
Yeah.
Then another, if you have this element here inside this region, it is within this right crescent moon. What does it represent? It represents event B but not event A. Can you see? Event A is here, but this dot is outside of A. So it's not A. Not A means the sisters are not next to each other. Is it clear?
Yeah.
And inside event, it's still inside the circle B, which means the brothers are all next to one another. So one example for this would be BBB. Then you want to insert a sister here, maybe a sister there, separated. Then what about this part in the middle? When they mention or both, what they're referring to is this middle part is also possible. What's one such example of a intersection here? It will be sister, and maybe a blank space. I don't know. Doesn't really need to have a blank space. Then brother, like this. Is this okay? Is it clear to you?
Yeah.
Both are possible. So now take note that when you try to calculate the probability of these 3 cases, which is what the question is asking you to do, it's really just a probability of A union B, which is P of A plus P of B minus P of A intersect B. Is this okay?
Yeah. Okay.
This circle, that circle, add together, overlap, minus away 1 copy of the overlap, minus away P of A intersect B. So now, how do you find P of A? We already calculated it, 2/15. How do you find P of B? We already calculated it. Over here, all brothers are together. So it's 1/35. Must be careful, it's not 34/35. Okay, add them together, but you realize there's the overlapping part where both of them are grouped together. We don't want that. So we need to calculate this number of ways now. This part is this part, P of A intersect B. How do you get 12 factorial times 2 factorial times 3 factorial? Divide by 15 factorial is obvious, right? Divide by total number of ways without restriction, probability.
Yeah.
Yes. But now we focus on numerator. How do you get this 12 factorial times 2 factorial times 3 factorial? How many people were there again? 15 people. Break down into 2 sisters, 3 brothers, and 10 others. How many ways to arrange? You want to have the sisters and brothers all together. So that means we want to You want to use which method? Grouping, insertion, complement. All together. So it's
Grouping.
grouping, right? One group, one group. So how many groups altogether?
2 groups.
So you just have the sisters and brothers. You ignore all the others.
And 10 others.
Oh, so what's the total number of groups?
12.
12. Very, yeah, correct. 12 groups. That's why you have 12 factorial here. Clear?
Yeah.
Okay, then after that you multiply by 2 factorial and 3 factorial. Why? 2 factorial for?
The sisters, then 3 factorial for the brothers.
You're arranging the brothers and the sisters. Oh, the sisters can be sister number 1 on the left, sister number 2 on the right, or sister number 2 on the left, sister number 1 on the right. 2 ways, 2 factorial ways. Then this one, brother 1, 2, 3, also 3 factorial ways. I'm not gonna list them down. 1, 2, 3, 1, 3, 2, 2, 3, 1, 2, 1, 3, 3, 1, 2, and 3, 2, 1. I listed them all down already properly. But that's just 3 factorial. So don't care so much. Times 3 factorial, fine already. Then after that, this entire thing key in the calculator, you get 43/273. Done. Okay, good. Now move on to part 4. Find the probability that the sisters are next to each other, given that the brothers are not all next to one another. Can you tell me which part, whether this sentence looks very familiar to you? Yes, right, it should. Sisters are next to each other. Where do you see that? 1, 2, 3. Part 1. Brothers, given that conditional probability, brothers are not all next to one another. Correct, good. So let's just label them as event, I don't know, I like to call this event B, then call this event A. Then this will be, so what is part 4 asking us to find? Find what? P of?
P of B given A.
Okay, good. Which is equal to? Fraction?
P of B intersect A over A.
P of A. Okay, very good. So now we're gonna do that. So P of B intersect A. Next to each other and not all next to one another for the brothers. Have you seen that before? B intersect A. Sisters are next to each other and brothers are not all next to one another. Maybe we haven't. Okay, we'll see. Cannot remember. We just go down first. Yeah, so over here. Oh, they already start using the A and B notation. Oh, since they already did that, I better make sure I be a bit more precise with my notation. What is your, okay, we try to follow the answer key. A is the event that the sisters are next to each other. Oh, sorry, I have to follow their convention. This is A. Then event B is event when all brothers are next to one another. So actually this one, not all next to one another, is not event B anymore, it's B prime. Can you see that?
Yeah.
Because they use event B to be all brothers are next to one another. This one is not. So it's B prime, the opposite. Then now this will be actually P of, what is it? Something given something. What would that probability be? Can you try again?
A given B prime.
Yes, okay, good. Which is exactly, oh, you want to try? Yes, equals to?
Oh, the P of A intersect B prime over P of B prime.
B prime, very good, yes. Exactly what they did over here. Okay, good. So now we try to figure out, how to find this, A intersect B prime. They did a fancy formula here, P of A minus P of A intersect B. Basically, let's work it out again. 1, 2, 3, 4. A is 1, 2. B is 2, 3. B prime is not 2, 3, so it's 1, 4. What is A intersect B prime? A is 1, 2, B is 1, 4. Intersection is region 1, 2, 3, 4.
The one.
One only. So that means it's this left half. But you realize that this left half, left crescent moon, is like a or Pac-Man. It's like a Pac-Man or enzyme. I don't know. It's like P of A minus P of A intersect B. Can you see?
Yeah.
A intersect B is what? It's 2. It's just 2. So A, you take away A intersect B. It's really just 1, 2, take away 2, which is just 1. This is not formal math notation. This is illegal notation. 1, 2, 3, 4. A bit more precise if you're trying to define the 1, 2, 3, 4. So yeah, 1. Good. So that means that we can actually just take a P of A minus away P of A intersect B. Oh, P of A minus away P of A intersect B. But why is that useful? Because we have already found out P of A before. P of A is what? A is the event where sisters are next to each other, which is really just part 1's answer, right? 2/15. Okay, so you can just type in 2/15 here.
So I have to draw the Venn diagram.
Yes.
Okay.
Then it will help you to deduce this formula.
Okay.
Then P of A intersect B, it will just be 2/455, which is actually found from the intermediate working over here, the purple color. Okay.
Okay.
Yeah. So maybe it would be good if instead of calculating the final answer straight away, you try to evaluate the pieces part by part. Write it neatly like this, intermediate working, so that you can recycle the 2/455. Don't have to type it in again. As long as your handwriting is neat enough, you can recycle the 2/455. This is an idea called memoization. Memoization. I am not mispronouncing. Memo pad, the memo, MO. It basically means that whenever you have information calculated from the previous part, as long as you write it neatly in a way that is retrievable, the information, in the further parts, when you want to recycle the information, you realize you're using the same information. You don't need to go and recalculate and go through the logic again. No need, unless you want to double check your work. Just use 2/455 straight away.
Oh.
If your handwriting is neat, then you can just recycle. It's called memoization. Memo means memo pad, like your memory aid, post-it note, like a post-it note. If you put down the information nicely on a post-it note, you can just use the information. That depends on your handwriting. Okay, can. Yeah, I'm gonna whatever. If not, you go and recalculate. See if you have time during exam. Go and recalculate 12 factorial times 2 factorial times 3 factorial over 15 factorial. Can also. If you're fast enough. Okay, then divide by P of B prime. What's that? B is event all brothers next to one another. Then part 2 is your B prime, right? Remember B prime?
Yeah.
So you just use the answer from part 2. 34/35 is your B prime event. The probability associated with the event B prime is 34/35. So you just sub in with 34/35. Maybe I'll just highlight it like this. Here to here. And then, yeah, that's okay. Maybe one more highlight. The gray color from part 1 is linked to here. Okay?
Yeah.
Yeah, so you're just recycling information from part 1 and part 2 and part 3. And finally, you get your answer. Usually it's like this, part 1, part 2, part 3, part 4. They are trying to help you. Your answer from part 1, part 2, part 3 will help you in your answer for part 4. Okay? Good. Next one. Oh, not done yet. Oh no. Supplementary. Question 14. You didn't try, huh?
Haven't.
Okay. Yeah, okay. Now it's time to go through the question you requested for. Let me go and download. Do you need to rush off?
Not yet.
Okay. How much time do I have?
Like 1+.
Okay. Wait, all right. Let me see how I can get this downloaded. Okay, resume. Ken, let's take a look at this question. So you want to go through small angle approximation. We haven't had the time to go through Maclaurin series and this small subtopic under Maclaurin series.
Yeah, so I didn't know how to do the question.
Yeah, so basically, right, if you look at the Maclaurin series, MF26, if I can just find the MF26 first. Where's my MF26? Oh my goodness. Here it is. Okay. You will see the formula for sin x and cosine x over here and here. Yeah, this is the Maclaurin series. Here, what we need to understand is in small angle approximation, what you realize is that if x is very, very small, you raise a very small number, let's say 0.001 to the power of 3, what happens? Does it become bigger or smaller? A number that is smaller than 1, you raise to a power. Like just half power 3. Does it become bigger than half or smaller than half?
Smaller.
Exactly, that's a key insight you should realize here. So when we say small angle approximation, what we're realizing is that here, for higher powers, power 3, power 5, power whatever onwards, if your x is a very small number, like half, half is actually quite big. We can go smaller. Let's say 0.1, 0.01, or 0.001. You just try typing in a calculator power 3, power 3, power 3, x cubed, or even higher powers. You realize that the number becomes so tiny and insignificant. It only contributes to like the, don't know what, 15th decimal place or whatever. It will only change that 15th decimal place, and we don't really care about such small values. Okay, that's why we want to we can approximate the answer by ignoring higher power terms. Here, you need to memorize which are the terms that you throw away. For sin x, throw away x cubed onwards. Focus on x. So the conclusion is sin x is approximately x. Write this down somewhere on your paper and pen. On the question, you dig up that question you are doing and you write that down. That's the first thing. Second thing, cosine x. Unfortunately, you cannot just assume cosine x is 1. It is a bit too big. You see, sin x, we can just assume the first term of the Maclaurin series. Cosine x, just the first term is not good enough. 1 is not a very good approximation of cosine. So what we should do is to include the second term, and then we conclude. So therefore, cosine x is just approximately 1 minus x squared over 2. Okay, this one memorize, no choice. Right, the intuition is cosine x equal to 1, a bit too inaccurate. It cannot be just 1, it's independent of x. Any value of x, you change the value of x, your cosine should change as well. Cannot just be a 1. That's why you need to have another term, x squared over 2. Okay? The power 4 terms throw away. Then for tangent of x, it's just x. It's just x. This one need to memorize. If you do physics, you will also need to know this. You don't, right?
Yeah, I don't.
Okay, it's fine. Just remember these 3. So with that, we can go on to try and answer this question. Here, the formatting of the question is wrong. This is very bad. I looked at the solution. I believe that you sent me. I believe this question is actually trying to ask you sine of 2x minus pi over 4, the bracket around 2x minus pi over 4, all divided by 2 minus sine x. Is that okay?
Yeah.
Yeah, so they phrase it wrongly. So how we do it? 2x minus pi over 4, you need to make sure that you use wait, let me just double confirm with your solution if this is the correct way. Yeah, you need to use let me think a little bit. Sorry. Yeah, you need to make sure that there is only a single term here. When you see 2x and minus pi over 4, the 2 times x is still okay. You can just keep it, tag it, it can tag along with the x, it's fine. But the minus pi over 4 here is not fine. Because if you look at the formula, we only allow a single x term. But we can also modify into 2 times of x or 3 times of x. Or in other words, sine of, let's say, qx is just approximately q times of x. cosine of qx will be approximately 1 minus qx bracket square over 2. Notice I'm putting brackets around qx. Sorry, my handwriting. Let me try again. Bracket qx, close bracket square. Then tangent of qx will be approximately qx. All right?
Yeah.
Oh yes, one more thing I should show you. Here, how to intuitively remember that sine x, sine x should be x. Think of it like this. Here's the sine curve. Here's the y equal to x curve. Notice that for very, very small values of x, here's a small x. The y coordinate, this is y equals to, okay, let's just give a concrete number. Let's just say that this is 0.01. Oh, this will be 0.01. And at the bottom here, if you can see the pink color one, this is sine of 0.01.
Yeah.
Type in a calculator for me in radian mode, sine of 0.01. What's the value approximately? Sine of 0.01 is?
0.01.
Sine of 0.01 is?
0.00999.
0.09998. Isn't that approximately 0.01?
Yeah.
Right. That's why this is a good approximation. It's because of the graph. It looks, if you look at the graph of y equal to x and the sine x, for very small values of x, the difference is only very, very tiny. You see, the difference is getting, as of course, if you make the x larger and larger, the gap is bigger and bigger. But that's why we want small angle approximation. We want smaller value of x so that the gap is very, very small, very, very tiny gap. And in this case, what's the gap? Let's just actually calculate this. The difference here is really just 0.000002. You see, it's so close. They're almost exactly the same. Okay, yeah, that's the point of small angle approximation using a graph. That's for sine x. You can do something similar with the cosine x and the 1 minus x squared over 2 graph. You can draw on your GC y equal cosine x. Draw on your GC 1 minus x squared over 2. You realize that it will look very similar. Oh, you want to do that now?
Draw.
Like y equal cosine x, 1 minus x squared over 2. Oh, maybe I can just should I just do it now for you so that we can?
I'm doing it now.
Oh, you're doing it now. Okay, I can also show here. X squared over 2, right? Oops, over 2. Yeah, zoom standard.
Ooh.
They look very, very similar to each other, right?
Yeah.
Okay, let me just change the scale a little bit. Okay, actually, if you're convinced, can I just move on?
Yeah, can.
Cannot. Okay, let's see if I can get a good graph. Wow, it's slow. Yeah, so you realize the graph look almost the same at the curve at the front.
Yeah.
Yeah, that's why we can use it as an approximation. Okay, good. Tangent, you can also do the same thing. Tangent x and x, they look the same at the beginning near the origin. Small values of x, for small values of x. So problem here is that we only allow a single term. Single term. Here, how many terms do you see?
2.
2 terms. So that means that you actually need to use your sine A minus B formula. Remember? Sine A minus B?
Yeah.
If not, then it's over here, available in the MF26. Okay, I'm just going to use it. So we're going to evaluate the numerator. Becomes sine A cos B minus stay as minus cos A sine B. Over here, the brackets is optional. You put, you don't put is both okay, because it's just a single term. And 2 minus sine x. I'll just put it. This is an exact equal sign. Oh, I'm running out of space. Hold on a second. And then I hope you remember from your A max your exact values. What's the sign of pi over 4? What's the cosine pi over 4?
Huh? I don't remember.
Yes.
Okay,
if not, then here's the trick. Remember, there's always a square root. Type this in a calculator already, then you square it. What do you get? Ooh, wow, my cursive pi. What do you get after you square it?
half.
So what is the opposite? So before you square it, what do you think is the exact answer? Opposite of square is?
Square root.
So you take the square root of 1 over 2. That's your answer. Which is 1 over square root 2. Remember?
Yeah.
Good. Then you can just replace it. Here, just an important point to take note. When you are writing trigo and then a number, try not to write it side by side like this. It may be misread as 2 times 1 over square root 2 then times x. And you're taking the sign of this entire thing, which is very bad. So the recommended strategy is to just bring the number to the left to avoid confusion. Is that clear?
Yeah.
How about sine pi over 4? Also 1 over square root 2. Do you understand this part?
Yeah.
Or divide by 2 minus sin x. So far, I have yet to use small angle approximation. I am just using trigo identity. So these are all equal signs. Now I am going to use trigo identity. Okay, wait, one more step. I do a bit more algebra. I factor out 1 over square root 2. And 1 over, I can bring the square root 2 down. So what this means is I will have another step, still an equal sign, but I'll bring my square root 2 down. So square root 2 multiplied by, okay, the 1 disappears. Square root 2 multiplied by 2 minus sin x. Is that okay?
Yeah.
And finally, we are going to use small angle approximation now. So just a recap again. Small angle approximation request for small angle approximation request for sin x to be x, cosine x to be 1 minus x squared over 2. So we're going to do that. But this time, sin 2x, right? The x can replace with 2x. So x here gets replaced with 2x. So sine of 2x here, x got replaced with 2x. So it just becomes a 2x. Is that okay? And at this stage, you cannot put equal anymore, must put approximation.
Oh, okay.
How about cosine 2x? What is it? Is it just blindly or minus? There's a minus, so you must put an open bracket. So is it just 1 minus x squared over 2?
No.
Wrong. What should it be? Open bracket?
Is it 2x then
Close
square?
bracket? Then square. Yes. Then close the bracket again. Good. Then square root 2 is square root 2. 2 is just 2 minus sin x is what?
X.
Correct. Yes. Then you proceed to simplify. So now this is equal to 2x minus away 1 minus 4x squared over 2. Simplify, cancel off. This becomes a 2x squared. So this becomes 2 root 2 minus away root 2x. This equals to, let's see, 2x minus 1 plus 2x squared over 2 root 2 minus root 2x. What did the question ask again? Let me read the question. Show that it's approximately square root 2 multiplied by -1/4 plus px plus qx squared, where p and q are constants to be determined. Okay, can. Okay, I better copy down the question because I can't remember. Okay, how? You need a square root 2, is it? Okay, then I can, I guess, factor out a square root 2. Does it make sense? Right. Sorry. Can I just follow the answer key? Because distributing the square root 2 here is not such a smart idea.
Oh, okay.
Okay. Here's what I should do instead. The numerator, I can simplify it down into 2x minus 1 over 2x minus 1 plus 2x squared over this denominator root 2 times 2 minus x. But I can do the following. I can bring this root 2 over 2 minus x up. So in other words, I'll end up with 2x minus 1 plus 2x squared, bracket, multiplied by root 2 times 2 minus x to the power of what? Bring it.
-1.
Very good. -1 just means 1 over. Oh, that's how you get this at the denominator. But if you work backwards, of course, you have to reintroduce the -1 power. Okay, good. So now what is so special about this -1 power is that you can actually do something. Okay, so actually that's not very good. What's so bad about this -1 power is that you need to distribute it. So over here, like over here, lucky for us, it's multiplication. So we can distribute the -1 power to each of them. So we end up with square root 2 power -1 times 2 minus x power -1. Okay? Can I ask where did this paper come from?
The tuition center.
Oh, tuition center. Okay. Because I need you to take note that 2 minus here, when we have a 2 minus x to the power of -1, right? It actually requires us to use binomial expansion, which is available in the MF26. Okay. Technically, binomial expansion has been removed from the syllabus. But over here, the part where the power is a rational power. Over here, lucky for us, it's wait, hold on. Sorry. No. Yes. It's already been removed from the syllabus. So technically, this part, you're not supposed to know it. Okay? It wasn't taught.
The binomial expansion.
Binomial expansion where the power is not a positive integer is no longer in your syllabus. It's in further math.
Oh wait. Oh wow.
Yeah.
But I thought it's in the MF26.
Correct, but it's still provided. MF26 is used by both further math and used by everybody. Yeah. So yeah. I'm pretty sure it's not in your syllabus already, but we can just use the formula. Okay. So let me demonstrate how to use it. You see, you look at the binomial expansion. What did they tell you about n?
It's a positive integer.
Here we got power -1. It's not in our syllabus anymore. The one that is a negative power, you actually need to use this version of the formula instead. Maclaurin expansion.
I need to factorize.
Factorize? No, you just use the formula and factorize a little bit so that you can get it into this format. Binomial expansion not in the formula, but not in the syllabus, but it is under Maclaurin series, so it could appear as a special application. Because the syllabus now is focusing more on application. So over here, let's look at the formula. We got 1 plus x to the power of some power. Notice the 1 here, very important. It has to be a 1. Here, x can be a bit more relaxed. X can be a q times x, still okay. You can still replace all the x that you see with a qx, or 2x, 3x, 4x, whatever. But here, the 1 is non-negotiable. Must be a 1. Has to be a 1. Must be a 1. And also must be a plus. Okay? Sorry. Non-negotiable 1 and plus. So that's what we're going to do. I need to force out a 1. But here is a 2 and a minus. How can I possibly do that? Let's do it at the side. 2 minus x power -1. Can you see that within the brackets? Let me just change the bracket into square brackets now to make it obvious. 2 minus x, I can factor out a 2, right? Can you see that?
Yeah.
But wait, isn't this really just the same as 2 times 1 plus negative x over 2?
Yeah.
I remove a pair of brackets. Is it more obvious now?
Yeah.
Then after that, you got something multiplied by something power -1. Isn't it just the same as if you remember a power b power m? A times b power m. It's just a power m b power m. Okay, so same thing over here is 2 power negative 1 times 1 plus negative x over 2 power negative 1. Agree?
Yeah.
Good. Now we have it in the correct format. 1 plus something power negative 1. It's just that instead of the x, it's a qx, where q is a negative half. Instead of x, it's a qx, where q is a negative half. Negative half multiplied by x replaces the x in the formula list. Let me copy down the formula list, the formula, and then I will use it over in the working. So let's take a look over here. 2x minus 1 plus 2x squared. Let me just write it nicely. 2x squared plus 2x minus 1. Then you multiply by root 2 power negative 1. And then you multiply by this guy, get replaced with this guy. So it's just 2 power negative 1 here times 1 plus negative x over 2 power negative 1. So everything else can copy down. But the front part here, root 2 power negative 1 times 2 power negative 1, what would that be? Negative half, negative 1. So it's 2 power, what is it?
Negative 3 over 2.
Negative 3 over 2, right? Good. So that's what we're going to get here. I'm going to replace this with 2 power negative 3 over 2. Then after that, this 1 plus minus x over 2 power negative 1, you can actually use the formula now. So let's see. What do you have? 1 plus nx. So 1 first plus n times x. What's n in this case? N is the power. Can you see the power?
Yeah.
So the power here is what? Negative 1. So what do you put in over here? Negative 1. Okay. Then you add on something. What is it? N times n minus 1. Divide by 2 factorial times x squared. So what is this and what is that? N is negative 1. Then minus 1, right? That's a pattern. How do you go from n to n minus 1? You just subtract 1. So it becomes minus
2.
Exactly. Then after that, you go on to the next term. But do we need that? Let's read the question. The question requested for up to qx squared. Qx squared. So do we need x cubed terms onwards?
Don't need.
Higher power terms don't need anymore. It's not relevant to the question. That's why I just end off with a plus dot. Clear so far?
Yeah.
Then now we proceed to multiply. Then we try to get our 1/4. Remember the 1/4? No? Okay, I go back to the question. Negative 1/4.
Yeah.
Okay. Then now we have to simplify it into square root 2 and as a factor outside, and then you need to get a negative 1/4 out. Okay, let's do that. So over here, 2 power negative 3 over 2. I realize that it's just 1 over 2 to the power of 3 over 2. I'll just leave it as that. Multiplied by, I'll copy and paste the rest. Copy and paste. Maybe I'll simplify this down as well. 1 minus x. Negative times negative is positive. So you get 2 over 2, which is 1. So this cancels off, becomes a 1. So plus x squared. Is that okay?
Yeah.
Plus dot dot dot. Okay, just end off with a plus dot 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 at the end. Now you can start to expand. So let's just do it. Okay, now we want quadratic terms. So x squared times x squared, is it relevant?
No.
No. Then we go on to the next one. X squared times x.
No.
X squared times 1.
Yeah, can.
Yeah, so we're down to 2x squared. Then we go on to the second term. 1, 2, 3. 2x times, sorry, I'm doing it in a very funny way. I'm doing it from the right to the left. Usually I do from left to right. Right. But I'm going to do from right to left so that I can get the highest power first. So 2x times x squared, is it relevant? No, x cubed. 2x times x, is it relevant? Yes, you get x squared. So negative 2x squared. Then next one, 2x times 1. Relevant, so plus 2x. Next one, all relevant. Okay, so -1 plus x minus x squared. -1 plus positive x, then negative x squared. Clear? Is it okay? Oh, sorry. I made a mistake. Can you see the mistake? Remember I talked about the q?
Yeah.
Q is negative half. I
So it
forgot to
should be
replace it.
times half.
Yes, correct. Yes, I need to correct everything with a negative half x. Negative half x. Then I square it. Okay, so we have to simplify it. Oh no, restart. Have to simplify first. Huh? So negative times negative gives you positive, then you get a positive half x. Next one, negative times negative gives you positive, 2 over 2 gives you a 1, so that's a positive 1. Negative half bracket square becomes a positive 1/4 x squared. That's the first sign of a positive 1/4. 1/4 that we are interested in. Okay, so now let's continue and expand. So x squared times x squared and x is not relevant, so just 2x squared times 1. I get 2x squared. Next one, 2x times what do I want? X squared, not relevant. X, relevant. So 2x times half x, you get a plus 1 x squared. 2x times 1, you just get a plus 2x. Okay, you're done with 2x already. Now we move on to -1. Here, here, then here. So now you end up with -1 minus half x minus 1/4 x squared. Is that okay?
Yeah.
Can I? I'll just save some time. I'm going to rearrange it a little bit. Minus 1/4 x squared is going to go on the left, plus 2x here, minus half x here, minus 1. Okay?
Yeah.
Okay, continue. Then we combine all the like terms. 2 plus 1 minus 1/4. What do you get? 11 over 4. Okay?
Yeah.
Good. Then 1 over 2 power 3 over 2. Then the rest I just add on. Also, what do you have? You have 2x minus half x. 2 minus half. That's 3 over 2. Then after that, you have a minus 1. Okay? Good. Now, how? We need what? What do we need? We need our negative 1/4. I copy down the question again to the bottom. Okay, I need square root 2 in front and negative 1/4 inside the brackets. So how? Here I see a -1. I need negative 1/4. What do you think I should do?
Divide by 4.
How do you go from a negative? Let's say we deal with this very, very simple example. Let's say I want you to force this -1 to turn into a negative 1/4. You actually divide by 4, right? But that means that you actually need to times 4 at the front so that it stays equal. Balanced out. But if you divide by 4, can you just divide by 4 to one term? Cannot. So you actually need to divide by 4 to the other term as well. So plus x over 4.
Yeah.
You see that? What you're really doing is you're factorizing out a factor of 4, but not forgetting the 5 in front. Okay? Can now? So that's exactly what we're going to do. So factor out of 4. What do you end up with? 1 over 2 to the power of 3 over 2 times 4. Then everything else you have to divide by 4 now. So 11 over 4 square, which is 16. X squared plus 3 over 2 times 4 is 8. Then minus away 1/4. Is that okay?
Yeah.
Okay, good. So what is 4 over 2 power 3 over 2? Let's figure this out. Let's do it at the side. So 4 over 2 power 3 over 2. That's just 2 square over 2 power 3 over 2. That's just 2 to the power of 2 minus 3 over 2. 2 minus 1.5. That's 0.5. That's a half. Is that clear?
Yeah.
But what's 2 power half? Forget already. Or is it the audio? What's 2 power half? Square root 2. Must remember, okay? Square root 2, Can. Then therefore you'll get negative 1/4 plus 3 over 8x plus 11 over 16x squared plus dot dot dot. Sorry, I forgot to write down the plus dot dot dot. Technically, you need to have the plus dot dot dot. Okay, can. Then what's your P, what's your Q, and what's your what's your P and what's your Q? P will be 3 over 8. Q will be 11 over 16.
Yeah.
Okay, good. That is the first question. Next, you got another question on vectors. Let me just hold on. Let me just go and download the photo. By the way, the lambda question, is it okay already? I answered like on 6 August, few days back.
Oh yeah, that one can. I didn't realize.
Can understand already. Good. Okay. Let me just go and download first. Wait a minute. How do I okay, and here. Okay, and resume. Oh, yes. Oh, here. Okay, Ken. Your part 1, is it okay? I haven't had the time to read the question.
No, I couldn't find anything.
Okay, okay. Let's just take a look at the question. I probably need more space. Few things you should remember. A dot B is mod A mod B times cosine theta. If A and A, if you take the dot product between two same vectors, it's just the modulus of that vector square. Okay, then if the angle is 0 degrees, 90 degrees, or 180 degrees, there are special cases. For dot product, 0 degrees means they're the same vector, so it means that you'll end up with cosine mod A times cosine 0, which is 1, which is mod A square. Then if it's 90 degrees, it will be 0, because cosine of 90 degrees is 0. Is it right? Yeah, correct. Then if it's 180 degrees, it will become negative. So, oh, sorry, I meant to write a B here. It will be negative A dot vector B. Okay, yeah, those are the properties you need to know. Yeah, Ken. Moving on. Let's read the question. The figure below shows a rectangle OACB. By the way, can you see my shared screen?
Can.
Okay, good. Can hear audio as well. Yes.
Yeah.
Good. Okay, the figure below shows a rectangle OACB where OA equals to OB. And point D is on AC produced. So it's in the same direction, just longer. Such that AD is to DC. AD is to AC is in a ratio of lambda is to 1. So lambda here is to 1 here, where lambda is a constant. The lines OD and AB intersect at the point E. It is given that vector OA equals to A, OB is B, and angle OEA is theta. OEA is theta. Now find the vector OD in terms of A and B. OD is here in terms of A and B. Then show that OD dot with AB equals to lambda minus 4 times mod B squared. Okay, so I see a mod B squared, I definitely need to involve this formula already. Probably, okay, I'm not sure.
Okay.
All right, one more idea you should know is the A dot B, take the modulus divided by length of B. This is the length of what? Length of?
A projection.
Projection, shadow. Michael Jackson shadow. Okay. Touchlight on top. Then there's a shadow at the bottom. That's what this is referring to.
Yeah.
Yeah, can right angle. Okay, moving on. So find OD in terms of A and B. Okay, let me think a little bit. How would you do that? It's a rectangle. Is that useful? Not so sure. OA is twice of OB. So that means that the length of OA is double that. B is half of that length A. In terms of length only. Oh, not it's just OA equals to 2OB. It's just in terms of the length, not vectors. They are obviously not half of each other because they are in opposite. They are perpendicular to each other. They are not in the same direction. Okay. Can. So since this is a rectangle, do you agree that vector OB is equals to vector AC? Other way around. AC equals vector OB, right?
Huh?
Yes, right? Yes. Then in that case, do you agree that AD in this case, it will just be lambda over 1 of vector AC? Can you see that?
Why?
Because AC is 1 unit, AD is lambda units. Okay, just if you're confused, you can use lambda. Let's say pretend it's 7. How do you go from 1 unit to 7 units? Just times 7 over 1. Times 7 over 1. And it's in the same direction. Okay. How about let's say I have a simpler example. Actually, no, a more complicated example. Let's say that I have this ratio here. The length here and the length there, ratio is 2:9. A, then B, then C. Okay, I don't use the same letter. Let's say I use P, Q, and R. This is a totally irrelevant question now. PR, can you express PR in terms of vector PQ? Vector PR in terms of vector PQ? The ratio of PQ to PR is 2 is 9. So
it's 9 over 2 PQ.
Very good. You got it already. So same idea, lor. So 7 over 1 PQ. But of course, it's not actually 7, right? What is the ratio? It's lambda. So so that's why it's lambda over 1. Is it clearer now?
Yeah.
Just lambda AC. Why? Why did I find lambda AC? What for? Oh, I mean, what for did I find vector AD? Let's think about it. What do you want? You want to find out vector OD. Triangle law. Can you see a hidden triangle over here? Sorry, my triangle curvy, like this here.
Yeah.
So vector OD is actually equal to what? Break it down.
AD.
Very good. Okay. So OA we know is A. AD we know is lambda of AC. Is that useful? Maybe, almost. What is AC? AC is OB, right?
Yeah.
Then therefore you get A plus lambda B. Oh. Then?
Oh, okay. Yeah.
Right, you just need to be able to see a hidden triangle. Any triangle will work as long as it involves the OB and OA. Here, what I was thinking before I start talking was that I saw AD, then I think, okay, I definitely need a triangle. I need to involve OA and OB. Okay, I draw OA. The moment I draw it inside my head, I see OA, I see OD. Oh, I automatically completed the triangle from here. The moment you draw 2 lines, it's obvious, right? The triangle. Can you see or not? Just automatically fill in the blank AD. Is it clear?
Oh, yeah.
Then from there you can, and then I was working backwards. OD is what? OA plus AD. But how do I relate AD to a missing vector? I haven't involved vector B yet. How do I link them together? I think, and then I look at your ratio. Oh, you label very clearly lambda 1. I know already. I can scale the AD back into AC, and I know AC because it's a rectangle, it's the same as OB. That's how I link them together. Is it clear?
Yeah.
Yeah. Maybe there are other ways to do it. I'm not so sure. Okay, so that is vector OD in terms of A and B, and show that OD dot with AB equals to that fellow over there. So what is AB? B minus A, right?
Yeah.
This one, fine. I answered the question. AB equal B minus A. So that means that OD dot with AB, the left hand side, maybe I'll just write down very formally like LHS equals to this guy. Then I replace the OD with what? Whatever I just found, A plus lambda B. I take the dot product with AB, which is B minus A. Is that okay?
Yeah.
Then after that, you need to show it's lambda minus 4 times mod B squared. Then you just have to use modulus properties already. Tell me how to expand.
Is A dot B plus A plus lambda times modulus of B square.
Good.
Then minus modulus of A square plus lambda A dot B.
Plus or minus?
Minus.
Should be a minus lambda A dot B. Okay, much better. Then here you got 1 lambda AB. Sorry, 1 AB. Here you got minus lambda AB. What can you do? Factor out the common factor. What are you left with in front?
1 minus lambda.
Very good. 1 minus lambda. Then plus lambda modulus B square minus modulus A square. Actually, at this stage, I'm a bit confused already because I need to look back at the question. They want lambda minus 4 modulus B square. Only got modulus B, length of vector B. In other words, the length of OB, right? So in other words, this is just lambda minus 4 times length of OB square. OB only, right? OB only. Here we have modulus A, which is the length of OA. How? Let me copy down the question to the bottom so it's easier. And also my modulus properties, let me just copy it down. Okay, length of projection not needed, but yeah. You need to start combining all these properties already. How? What's A dot B? Let's calculate that first. Where's vector A on the diagram? Here. Where's vector B? There. What's A dot B?
Let
me give you another hint. What's the angle between them?
90 degrees.
So what's A dot B?
0.
Yes, it's 0. Go song. Gone. Clear?
Oh. Okay.
Okay, good. Then lambda B square minus A square. Hey, how? Why? Got modulus B, that's just OB square. So lambda OB square. Okay, actually I wanted, at the end of the day, it's lambda minus 4 times modulus of B square, right? So how? There's the odd one out. Can you see the odd one out is the modulus A? How can I link it back to modulus B? Don't need that. Read the question again. Sorry?
Is 2B.
Very good. Length OA is 2B, but actually your notation is wrong. You shouldn't say A and B. A and B, if you didn't put a tilde, it would be, if you didn't put a tilde and you purposely meant to not put a tilde, then okay, I can accept. It's a length. If you accidentally forgot to put a tilde, you meant to write a vector, and then you're saying it's 2B, you're saying that vector B equals to half of vector A, then I will be angry and tell you this is wrong. This is totally wrong. Why? Direction different. Direction different, okay? This is wrong.
Oh,
Even though the length is half, the direction is different. So in the world of vectors, you cannot just say that they're equal to half of it. Only the length is half. In other words, the modulus of the vector is half. In other words, you got the right idea. B equals to half A, but you cannot write it as B equal to half A. This is bad notation. Instead, you should say the modulus of the vector B is equal to half times of the modulus of vector A. Is that clearer? This is correct. That is wrong. If you put in a vector like this is even worse. Wrong. Okay?
okay.
Only the modulus equals to half of the modulus. That's the only the modulus can be related to the modulus, the length. Modulus is a scalar, not a vector. So now let's just replace the modulus A. Maybe I can make modulus A the subject instead, so it becomes 2 times of modulus B. Is that better? So you can, does that make sense first? It is definitely better, but does this make sense? Times 2, Okay, good. So now lambda mod B square minus away modulus A square. What's modulus A? It's 2 times of modulus B. Correct or not?
So
Okay.
it's 4.
Yes, that's how the 4 comes about. Lambda times of modulus B square minus away 2 square times modulus B square. Right, just distribute the square. So 2 square is 4. So lambda minus 4 factor out. Then you are left with lambda minus 4 multiplied by modulus B squared. Good. Clear?
Yeah.
Okay, good. Then the other parts, is it okay? I haven't read yet. I'll just go through.
I couldn't do the first one, so I cannot do the subsequent.
Okay, can. Let's just read. So in the case when E is the foot of perpendicular from A to OD, perpendicular means this is 90 degrees, is it?
Yeah.
Oh, no. It doesn't look 90. Bit funny. Why is it not drawn to scale? Not sure. Deduce the value of lambda. Okay, let me think. OD with AB. Oh yeah, correct. If it's a foot, then it should be a 90 degrees. This is in the case. In the case means it's only applying to part 2. In part 3 onwards, it may no longer be the case that E is a foot of the perpendicular. So this angle here, for now in part 2, we pretend it's 90 degrees and 90 degrees. Later on in part 3, it may change. I haven't read part 3 yet, so I don't know, but it's okay. I can just assume it's 90 degrees. So what do you conclude when it's a 90 degrees?
The A dot B 0.
Very good. So you can actually solve part 2 without knowing part 1. You can use the answer from part 1. Can you see how you can use it?
Oh, the lambda minus 4 B square modulus B square.
Yep. That will be equal to
0.
Yes, correct. Vector AOD dot with vector AB, they are perpendicular. So it's equals to 0. Because they are perpendicular. Okay, I should write this down. OD is perpendicular to AB vector. Vector OD is perpendicular to vector AB. Therefore, their dot product is 0. So we have a formula on the left-hand side. Replace lambda minus 4 multiplied by modulus B square is equal to 0. Something square is always more than or equals to 0. A length square is always more than or equal to 0. Or you can argue that a length is obviously positive. This is a length of a rectangle. How can it be 0? So if it's not 0, it can only mean lambda minus 4 is 0. Solving, you get lambda equals to 4. Can? Is it clear? Okay, good. That's part 2. Part 3, using this value of lambda equal to 4. Okay, so we can assume that since they asked us to use that lambda, we can also proceed to continue assuming this is 90, that is 90, even though the diagram looks very, very bad. It doesn't even look 90 here. but you can trust that it is 90. So the diagram is not drawn as using this value of lambda and given that vector A and vector B are the following, find vector OE and then find the length of the vector OE. Find the length of vector OE. Sorry, are you still connected?
Yeah.
Audio. Can I? Okay, can. Yeah. All right, because I saw you got mute. You mute yourself. Okay, it's fine. It's fine. Just let me know if you cannot hear me.
Okay.
Now, part 3. Using this value of lambda, we know lambda equal to 4. So that means what? That means we know a few things. Here it will be a 4. Here will be a 4 minus 1 units. I'd like to draw a circle to represent units because they are not actual lengths. I may mistake it for like 4 actual cm or something. So I draw a circle to remind myself, oh, it's not actual, it's not an actual length, it's just a ratio. Okay, how do I solve this? Let me think. OE, you want to find vector OE. Let's see. Okay. Can you see a hidden right angle triangle here?
Yeah.
Okay, we're gonna translate that into our diagram here. There's a point A. It's a bit small. I hope you can see.
Okay.
Now theta is equal to 90 degrees because E is still assumed to be the foot. We are still assuming lambda equal to 4, which means that the E is still the foot of the point A to the line OD. So there's a O point D here. Then this OA is vector A. This OD is what? OD was what was OD again? A plus lambda B. A plus lambda B. Oh. Then we want to find vector OE. This is what we call the projection vector. Okay? Or you know how to find OE, right? The length. What's the formula?
The modulus.
Okay. Actually, wait, sorry, they didn't ask for projection vector. Oh, they asked for the length of the projection vector, which is the length of projection. Yes. So what is it? Formula. Michael Jackson, plank, floor. 忘记了. Oh no. Okay, where is it? Okay, I give you 3 seconds to memorize this. 3, 2, 1, gone. Okay. What is it?
The modulus A dot B over B. I know this one, but I don't know which one is the A and which one is the B here.
Oh no. Must remember, this guy is Michael Jackson. This guy is Michael Jackson. This guy is your floor. Your floor. Okay? Remember? I show you a picture of Michael Jackson. He's wearing his Smooth Criminal.
Yeah.
And then the touchlight above. Must remember this diagram, okay? So it must always be this guy against that guy. Michael Jackson against the floor. So Michael Jackson on the left, dot product with the floor, divide by the length of the floor. Modulus at the top to ensure it's positive. Dot product. Because dot product sometimes can be negative. We want positive only. Okay, so now contextualize. What would it be? Who's Michael Jackson?
The OA.
OA, so it's just vector A. Dot product with, who's the floor?
OD.
OD. Modulus divide by modulus of?
The OD.
Very good. Now we can fill in the blank. Actually, we know what's A, right? A was given to be, can't remember, 4, 4, -2. Oh, 4, 4, -2. So I'll just fill in the blank, 4, 4, -2 in my diagram. I'll draw a picture, please. Then B, vector B is 2, -1, 2. 2, negative 1, 2. I think if you practice drawing the picture, it will help you to memorize the formula better. Then you can visualize, oh, this is the Michael Jackson, that's the floor. Then cast a shadow over here on OE. Cast a shadow on OE, then that's the dot product. Michael Jackson dot product with floor over length of the floor. Okay, good. So now we can just fill in the blanks. We know the value of lambda as well, right? Use the answer from part 2, lambda equal 4. So I can just replace this with a 4. Let's just calculate this guy, factor OD first. 4 plus 4 times 2, that's 4 plus 8, which is 12. 4 plus 4 times negative 1, 4 minus 4 is 0. Minus 2 plus 4 times 2, minus 2 plus 8, 6. Okay, then we can fill in the blanks now. So just take 4, 4, negative 2 as vector A, dot product with 12, 0, 6 as your vector OD. Take the modulus to ensure it's positive. Give up by the length of the 12, 0, 6. Calculate this, what do you get? 4 times 12. Just type in the calculator. Everything. 4 times 12 plus 4 times 0 plus negative 2 times 6. And you get a 36. Divided by 12 square plus 0 square plus 6 square. Then you take a square root. It's a square root 180. This is exact value. It's better to leave as exact value because here they ask for length. 80 can rewrite as 9 times 20. 20 can rewrite as 4 times 5. 9 times 4, 36. So it's actually 36 times 5, right?
Yeah.
So I can split up as square root, which means I'll end up with square root 36 on top over square root 5, which is square root of 36 over 5. Or I can just change this into a 6. Actually, that looks nicer. So I get 36 over 6 root 5. At the end of the day, the 6 also can cancel off. Not much difference. Doesn't really matter. So you can also rationalize the denominator. So you get a 5 at the top. Sorry, 5 at the bottom. Square root 36 times square root 5 on top. What's 36 times 5? 180. So square root 180 over 5. Okay. That's all. Okay. I haven't had time to go through discrete random variables with you. Okay. Are you okay with it?
I haven't done the tutorial yet.
Okay. I think it's time to the probability supplementary, right? I think we move on already. We do DRV now. Okay. The discrete random variable. Can I just go through some questions with you? How much do you need to rush off?
Like by 2.
Okay. Let me try and give you a file now. Hold on a second. I am sending over to you in a moment. Give me some time to download this. I want to save and download. Hold on a second. Where is your name? Here is your name. I need to send. Oh yes, I am okay with the Tuesday time slot. I can permanently change to 7 Tuesday.
Okay, can.
Can. Thank you very much. Okay. I just sent you that worksheet. We're gonna try some of the basic questions first. Just recap on DRV for discrete random variable, it's just to lead you up towards binomial distribution. So let's take a look at the DRV worksheet. These are, I collect prelim papers, questions as well as some assessment books. So let's just take a look at question 1. Let's start you off with a simple one. For discrete random variable, you must understand that we always start off with a x, what we call a random variable, and it can take on different values. And in discrete random variable, these values are whole numbers. Okay, whole numbers, or actually more. Oh, I'm not sharing the screen. Whole numbers, or more precisely, it's integers. Then what we can do is we can construct a table to consider all the possible values. So here, little x, if you look at question 1, have you downloaded the file?
Yeah.
Here, this is a very simple example. You have 2 values for little x, 1 and 2. Then they take on the values a and b. All right, A and B. Then what does that mean? It means that maybe you're rolling a coin. Oh, sorry, rolling a coin, flipping a coin. Sorry. Then there's a 1 at the top and a 2 at the bottom. Okay. Then there's an associated probability with each of these cases. Then the probability here is A, probability here is B. So what do you know if this is a fair coin? Probability should be 0.5, 0.5, right?
Yeah.
But what if it's an unfair coin? Let's say one side I make it heavier, so let's say number 2 I make it heavier, so it's always landing on 2, so it'll show number 1 face up. So it means there's a higher probability of 0.6. But what's the corresponding probability now for getting the other result?
0.4.
Is it still 5? No, it has to be 4. Why? Because the sum must always add up to
1.
1. Okay, what else do you notice? This 0.6 and this 0.4, it's always more than 0, more than 0. Can? If you understand that, you already know most of discrete random variable. Now we can discuss, what's the first thing you need to know is that discrete random variable, the sum of all the probabilities, right, all these values in the bottom row will always be equal to what?
1.
1. Yes, so you get a first simultaneous equation. Okay, that's in terms of A and B, right? So here, since they want find the EX and variance X in terms of A, it means that the B here shouldn't be a B anymore. You should replace the B with a 1 minus A. Okay, so B here changed to 1 minus A. Clear?
Yeah.
Good. Then now we try to find expectation. Do you remember how to find expectation? Formula. Okay, I give it to you. Sum, it's just average. It's just average. Sum of xi, okay, xi, multiplied by probability of capital X equals to xi. I goes from 1 to n, where n is the sample size. In this case, you can think of it like this. This is like typically we don't use the index I until so much because it's a bit complicated. You can think of this as index xi. Then there's a hidden index I at the top. This is 1, this is 2. So this is x1. Right? If you know how to read the table like this, there's an index I equal to 1. So you substitute I equal to 1 along this column. So here is xi. It means that this will be, this 1 here is actually your x1. Then this 2 here, I is equal to 2. So that means this row is actually read as x2, little x2, curvy x2 equals to 2. Then over here, I put in an extra subscript I. It's actually probability of x equals to 1. xi, x1, which is probability of x equals to 1, equals to A. Okay? Then likewise over here is probability capital X. Random variable must be capital X. The little value here, the actual value that the random variable will take on, it has to be a small x. Must make sure you have the difference, okay? Capital X and small x must have must distinguish between them. But anyways, this is P of X equal to 1 minus A. So now let's use this formula. Sum of xi, sum of the x multiplied by probability. It's just telling you to multiply the two numbers at the top and the bottom. Sorry, the number at the top and the bottom. Top and the bottom. So let me just clean up this diagram again, but this time just with top and bottom, which is exactly what you can see in the question. Don't need so much details, just memorize this. When you want to find expectation, you take top minus bottom. Top times bottom, then you add them together, each pair. So in other words, xi in this case, this is actually gonna sum from I equals to 1 to 2 of xi multiplied by P of capital X equals to xi. In other words, this will be equals to x1 multiplied by P of x equals to x1 plus x2 multiplied by P of x equals to x2. This is just summation notation. But honestly, if you cannot remember all this summation notation, just memorize this for me. When you want to find expectation in a table question, just take the top number times the bottom number. You see a 1 and an A? Just take 1 times A. Plus, second column, top number, bottom number, 2 times 1 minus A. Is that okay? That's your answer already.
Yeah.
expectation is easy. Okay, just maybe simplify a bit. A plus 2 minus 2a gives you 2 minus a. Answer. All right, now we try to find variance. How? Variance, I hope you remember the alternative. There are two versions to this formula. First one is expectation of x minus expectation of x, or what I like to call mu. I let mu represent expectation of x. So this will be mu bracket square like this. This is exactly the same as ex square minus square ex. You know this, right?
Yeah.
Ex square minus square ex. Do you know the proof behind it?
No.
You just need to memorize this. Do you want me to show you?
Okay.
Okay, I'll just show you. Quick one. So let's go. So proof. Explanation is like this. No numbers involved. X minus mu square is really just expectation of x square minus 2 times x times mu plus mu square. Right? That's just a plus b bracket square formula. But then now, oops, let me just bring it back in. But then, oh, very messy. Expectation, I hope you remember, it's linear. Linear means what? You already seen linear before. Let's say you differentiate 2x cubed minus 2 square root x plus 5x. You can always split it out, right? So differentiate each term, right? Plus the derivative of the second term, negative 2 root x, plus derivative of 5x. This is called linear. But what else about linear? When you have a factor, what can you do?
Take it out.
Take it out. So 2 times differentiate x cubed plus negative 2 multiplied by derivative of square root x. Then 5 times derivative of x. So this is what we call a linear property. You can do linear operator. Here differentiation is what we call an operator. You can sort of distribute term by term. And then when each term has a factor, you can take it out. Same thing with expectation, it's the same pattern. You can also split it up term by term. So ex square, then plus e of negative 2 times x times mu, plus e of mu square. But wait, let's calculate what this is. Let's calculate what this is step by step. I hope you can see the pattern already, ex square. The formula you memorize so well, ex square minus square ex. Ex square pop out already. Okay? Then minus away 2 times x times mu. This is equal to, you can see a negative 2 here, you can see a mu here. Mu is just a constant, it's just the mean, the average. Expectation is average. So you just take negative 2 times a mu. Like you've learned mean, median, mode in secondary school. Mean is just the same as expectation actually.
Yeah.
Just more complicated. Minus 2 mu, then you multiply by e of x, right? Can you see? Factor out. Then after that, you add on expectation of mu square. Now, this one, expectation of mu square is really just a summation of mu square, I equal to 1 to n, then you divide by n. What does that mean? It means you take this constant, mu square is just some number, then you square it, it's just another number, then you sum up n times. But this is independent of n. So what happens? You're just gonna take the same thing, you add on n copies of it. So mu square plus mu square plus mu square, but n times. In other words, this is n times mu square. Okay? Which means that you end up with n mu square over n. N mu square over n, what's that? This is really just mu square. Okay? N mu square over n cancels off, you are left with mu square. Let's simplify the rest of the working now. So what do we have over here? We have an expectation x. Remember what was expectation x at the beginning? It's mu. Okay? It's just a mean. Mean for, or we use the letter mu. All right, mean, mu and sigma square. So mu is a mean. That means I can replace this with a, sorry, I'll do it at the top. Replace it with a mu, which means that I'll end up with a times mu here. So what is negative 2 mu times mu? Isn't that just negative 2 mu square?
Yeah.
And don't forget the plus mu square at the back. Okay, good. Then in that case, if you minus 2 copies plus 1 copy, how many mu square left?
1.
So minus 1 copy of mu square. So expectation of x squared. But what is mu again? Now we replace it back with the expectation notation. So 1 times expectation of x, that's the mu, right? Bracket, bracket, square. Bracket, bracket, square. Can you see?
Yeah.
Then that's where the pattern, that's where the formula comes about. Ex square minus square ex. Okay? This is variance, the expectation of x minus mu bracket square. In other words, if you want, you might have seen the following formula from O level Emax before. Or instead of using mu, last time it was x bar. Then divide by n. You may have seen this formula before.
Yeah.
Take the square of the distance between the data from the average mean, divide by number of data. Take the sum and then divide by theta. That's variance. Okay, Ken. Anyways, how do you calculate this ex square minus square ex? Ex you already know, but what's ex square? What do you need to do to your table? You need to get the x square. So previously we had what? Previously we had ex, or what do? We just take x times the a, x times, okay, sorry, let me try again. X times the probability, x times the probability. Now what we're going to do is we're going to upgrade. We are going to calculate what is x squared instead. So you take this table on top whenever you have space, now you can calculate for me x squared. So it will be 1 square, which is 1, 2 square, which is 4. Then this time, instead of looking at the x, I'm just going to use a red line and, sorry, let me just change everything to black color. Oops. And then now I'm just going to use a red line to cancel off this row. Do not look at the x row anymore. Focus on the top and the bottom. 1 and a, 4 and x, 1 minus a. These guys are your x squares. Okay. Then you just have to take the expectation. How do you take the expectation? You just take top minus bottom. Sorry, top times bottom. And you add them together. So ex squared will just be 1, which is 1 square, times a, plus 4, which is 2 square, times your 1 minus a. That's your ex squared. Is it okay?
Yeah, okay.
Then you minus away, okay, good. Then ex bracket square. What's ex again? 2 minus a. Remember?
Yeah.
Oh, all this working. Top times bottom, add them together. 2 minus a. Okay, then now you just need to simplify. So a plus 4 times 1 minus a is 4 minus 4a. Minus away, this one need to simplify. 2 square minus 2 times 2 is 4a plus a square. Distribute, you get a plus 4 minus 4a. Okay. Minus 4 plus 4a minus a square. I see a minus a square. Let's combine like terms. 1 minus 4 is minus 3, plus 4 is plus 1. So plus 8. I see a constant plus 4. I see a minus 4. No more. So that's all. Factor out the a, I get minus a plus 1, or 1 minus a. Answer. Can?
Okay.
Yeah, very simple. That's just the beginning. Maybe you can try the rest on your own. You want to try? Okay, wait. Let me think. Oh yes. One more thing to take note is sometimes they will give you piecewise functions. So if you look at question 3, I'll just give you I don't go through in full, I'll just give you some hints only. When they tell you p of x equals to r and p of x equals to r equal to 0 equals to kr for r equals to 1, 2, 3, 4, and otherwise, right, I strongly recommend you to draw a table. Okay, so construct your own table. Is that clear? Construct your own table. So you got little x and p of capital X equals to, okay, they didn't use little x this time, they used little r. Oh, then what are the values of r? 1, 2, 3, 4, and others. What does that mean? It means you can essentially think of it as there are many, many different values of r, but you just need to focus on the 1, 2, 3, and 4. So dot, dot, dot at the left, then 1, 2, 3, 4, then dot, dot, dot on the right. Then you fill in the blank. Follow the formula. When r equals to 1, which formula do you use? The top formula or bottom formula? Which one do you use, top or bottom?
The top one.
Top one, k times r. So in that case, it will be k times 1, which is k. Next one, if r equal to 2, what's your p of x equal to r? Which formula do you use?
The top one.
Still the top one, r equal to 2. So that means that you have, what is it? Is it still k? No, it's k times r, k times 2, which is 2k. What do you think is the next one? Which formula do you use? R equal to 3.
One.
R equal to 3 is here, so you use the top formula. So k times r. Fill in the blank. R is what?
3k.
So 3k over here. Next one, 4k. I think it's obvious. Then the rest is all zeros. All right. So now they've asked you to find the value of the constant k. What's the trick here? What do you know about the sum of all these probabilities?
1.
1. Then from there you can solve for k, right? I'll leave that to you. Sum equal to 1. Hint. Incomplete. Then part 2. Let's see. Illustrate the distribution. Describe the shape of the distribution. This one technically, can you cross out for me? When they ask you to draw the graph, right, you don't need. But I'm just gonna talk to you. Just gonna briefly describe to you how the graph will look like. Basically, there will be a bunch of lollipops. Here's 1. Here's 2. Here's 3. Here's 4. 1, 2, 3, 4, like this. Okay. Then you'll get a corresponding value, a y value, a probability value actually. And the sum of these heights, this height plus this height plus this height plus this height, all together is equal to 1 because they represent probabilities. You don't need to know this. If you study economics or something, then you may need to know. Okay, then for part 3, try on your own. It's just probability. And can I just assign this entire worksheet as homework?
Can.
In addition to the DRV from the EJC.
Can.
Right? Can All right. And that will be all for today.
Okay.
Okay.
Thank you.
And I'll see you on